Great. Week 7th, day first, week 7. It started as a pure information retrieval series. I used to first ever cohort. I used to basically cover so much of math in it. People repelled because seeing math. So then, and it seemed little less basically relevant because in real world you typically don't have to do that. So that's where I flipped it a bit, and now I covered this three part, and it's not at all math heavy. It's more about how you actually practically get things done. So the agenda for today will be we will design recent searches. Again, last week when we were discussing LSM tree, we went through a different route. We went through the route of innovation, right? And as senior engineers, we typically are not given a full-fledged detailed problem statement to solve. We are given ambiguous situation. So with recent searches, we would touch upon another way to put a problem statement, which is basically metrics driven. And then we would have to find solution to that. We'll touch upon that. Then we'll see, and then we'll design a very realistic, extremely realistic crick versus text commentary. Right? It's basically very simple, where a corresponding cricket match is live. There is a website, ESPN Cricket for CrickBuzz. CrickBuzz is India's 8th most visited website. On CrickBuzz, people read text commentary. Even I do it. I don't watch matches anymore, but I do read text commentary. And a lot of people do. A lot of people find joy in reading text commentary. So reading the text commentary, how that commentary gets, because there is a person writing that commentary, and there are, if not millions, at least a few 100,000 users concurrently reading that. How do you build system like this very realistically? And then we would conclude our discussion with on when you build text-based search engine, instead of going into internals of it, because it involves a lot of math, a lot of people were repelled by it. Obviously, it's there on my website if you want to, not a video, but math behind TF IDF in case you want to understand. But we'll touch upon that if you ever get to build a search engine, or if you work in a search relevance team in any organization, what are some relevance mechanisms that you should definitely know and how they impact the relevance of your search engine. These are the three things that we would be covering today. Okay, let's start with the first one. Ton of brainstorming today, except for the last one. For the first two statements, we'll do huge brainstorming. Okay, so understand the problem statement really well. What we are designing is we are designing recent searches. The idea is we want to show users the recent searches that user made. So if user A is coming onto the app, tapping onto the search bar, user sees the recent searches made by him or her. Right? The idea here is that whatever recently I searched, I want to see that on the screen. Right? And why so? Because you know that across, as in your business analyst team, or rather your basically data analysis team, they came to you with this thing that, hey, across the internet, it is seen that 50% of users. So you are not given, like you are serious, you are, let's say, senior staff at a company, and your CTO came to you and said, hey, these are the things, find a solution. They won't tell you you need to build recent searches. They won't tell you what exactly features you need. They give you these numbers and say, design a system. Simple. Because they don't care how you do it. They want, at CXO's level, they want a problem to be solved. They would never spoon feed you, hey, this is exactly what you need to build. These are the requirements. And all. You have to figure out. Right? And as senior engineers, you have to coordinate with product team and insights team and get things delivered. And that's the kind of work that you should thrive to do. Because this way, you are challenging yourself into not giving a very laid out problem statement, instead being thrown into a void where you don't know what you don't know, right? Okay, so someone from the insights team went to CXO, let's say CTO or CPO, and told them that, hey, we found these numbers really interesting. Can we do something around this product? We think that recent searches might be good for a product. The numbers that they said, the statistics that they said to the CTO or CPO were 50% of users tap on the search bar within first 5 seconds, which means when a user opens the app, within first 5 seconds, a user is very likely, or almost there is a 0.5 probability that a user will tap on the search icon, right? Which is insanely high. Insanely high. 50% of your users opening the app and tapping onto the search bar within first 5 seconds. It means that there is going to be very high traffic on this service. Not just traffic, but also use, like everyone would be using this thing what you are building. That's number one. Number two is 30% of all searches happens through recent searches, which means that when you tap on the search bar, let's say this is a search bar, you tap on it, you see recent searches, let's say 10 of them, right? You see last 10 recent searches made. It's not searched within your recent searches, right? Recent searches is simple. You tap on the search bar, you see the recent searches made by the user. When you search on it, it's a normal search, right? So this is recent search where you are seeing your recent searches. So when a user taps on the search bar, the user sees without tap, user sees the last 10 searches made by that particular user. Now, a user, like 30% of this traction, what you see is 30% of the times user would tap one of the items that he or she recently searched, which means that there is a very high, it's a very high ratio of the people coming onto this platform and tapping onto the search bar and searching from the recent searches versus making new searches on the platform. 30% significant traction, right? Which means that very likely 50% of users open the app, tap on the search bar, tap on the search icon, open the search screen, tap on the search bar, see the recent searches. 30% of them tap on the recent searches, like one of the recent searches that they see, right? That's it. This is what Insights team told CTO. CTO told you, build a system, right? No one's laid out what you want to render, how you want to render, what product interaction, figure it out, right? And this is the kind of situations typically early stage folks though do this day in and day out. Mid-sized company also kind of operate like this. Big Fang, they operate differently. They have full hierarchy and all. But this is where the fun lies, where this is a kind of situation which stays across all organizations, including FANG's big multinational orgs, because everyone is data driven. Every single company is data driven. Every single product decision is made considering data, because humans don't like to take blames for some hiccups that have happened, right? Or for some mishaps that happen, right? We just like to blame it on data. We follow the data, we can't do much, right? So it's that perception of humans that, hey, I don't want to be the punching bag, which I feel it's wrong, but I don't want to be the punching bag. So, hey, I'll just blame it all on data, that, hey, if data backs my decision, I'll do it, right? So given this as a common practice, as senior engineers, we are thrown into a situation like this, and now we have to build a system, right? Okay. So now we'll kick off brainstorming, and now that's all. There is nothing more over here. From this, we have to define the requirements. We have to define the solution. We have to architect so that we meet these constraints really well. Right? Now, few things that we would definitely be covering as part of this is understanding bounded data, unbounded data, importance of latency, importance of not having stale data. And one key factor that I would add to sprinkle some interesting part into this is we want cross-device consistency, which means that if your product is, let's say YouTube, let me take a concrete example. On YouTube, when you tap on the search bar, you see recent searches. If user has opened YouTube on mobile app and on web, if user search something on the web, the recent searches made by that user should be available on mobile devices. Like when they refresh the page, they should see the recent searches, or when they tap on the server, they should see the recent searches, right? So it's not that you just do it for one device. It needs to be cross-device consistent. Right? Okay, let's go about it. Now, for this, let's start storing with data, and then I'll help you brainstorm on different aspects of it and how we are designing. Right? Okay, and just keep those things in mind that these two metrics are really important for us to make any design decision. So any design decision we make should be backed by these to metrics. That, hey, why are we making this decision? Has to be backed by this data. And here you would always see 10 recent searches. It's not search within recent searches. No, it's simple recent searches. Tap on the search bar, you see last 10 searches made by the user. Okay, so let's start with storing the data because that's the easiest thing. Given this screen, what would you store? Let's start with storage. Raise your hands, I'll pull you in. Yeah, Rahul.
So I actually thought about the metrics and all of those things. So I actually thought about the requirements for this. Okay, so like first metric that you told us, like 50% of the users tap on the search bar. Okay, that means the service is being utilized a lot more than others. Okay, so the first thing that we should consider on is to reduce the burden on the search service. Basically, that should be our first objective here. Kind of like I'm laying out the requirements for this. Okay, first thing should be is to reduce the load if possible to the search service. Second thing would be for the recent storage thing. Okay, so there is going to be transaction of data for the if we build a simple system, there will be a waste of network, you can say, on basically transferring data for recent searches. If the user goes to web server every time. Okay, so basically for storing recent searches, what I thought of basically is to have uh, two s- uh, two types of storage. One will be the cache storage on the web browser, basically.
Cross-device consistency is broken. You can't have it.
Yeah. I will come to that. I will come to that.
No, first you are digressing the discussion. Let's focus on storage part. Then we will touch upon this aspect. Or whatever you said, we'll touch upon that. Right?
Okay,
Let's
sure.
talk about what exactly are you storing and how are you storing. Let's start with that.
So basically for that, we can have a no SQL DB for that. Okay. And which will have the
Directly making that decision NoSQL DB. Why? What is the rationale behind it?
So my rationale behind it is basically to have like some sort of a key value pair of which I can pick up immediately.
I can also do it on relational. Why non-relational? See, first always start with schema. What exactly are you storing? Then understand how much scale you are handling and then pick a database. Don't go other way around, right? What exactly are you storing? Let's start with that.
So what I'm storing is basically I will be having some user and and will be having some user searches which he has done in the past, like let's just say 4 or 5 searches.
We are showing 10 searches, so you'll store 10 searches.
Yeah.
Okay. You'll store only 10 searches over here.
Yeah. If we are like showing 10 searches to them.
Okay. Now wait. What is this one search look like? Only a string?
It should be, I think, some sort of ID, actually.
Search ID? What is a search ID?
So, let's just say, there are some similar searches, like Megan Trainor, anything like that, Justin Bieber or something like that. Okay, people do such type of searches. So let's just say if multiple people do that, I don't want to store the whole string Justin Bieber or like how Justin Bieber mom or anything like that in the user data actually.
Imagine how complex your system would be. Here you are storing IDs, then you are making a network call to get the actual data. Why? You need very fast response time. You only said it's very high performance service. 50% of users tap on the search bar to render recent searches, right? Yeah. Now imagine you you're storing references. For example, search ID, whatever you're calling that. Imagine you want to get an actual search query, how slow the system would be. Correct? So store the actual string. What's harm in that? No harm in that, right? You would
I
exactly store the data what you are directly going to render. Plus, I giving every search query a unique ID. That ID would itself be 8 bytes long at least. At least 8 bytes long. Given that your ID itself is just 8 bytes long, instead of storing Justin Bieber that you given as an example 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Instead of storing 11 bytes, you went with 8 bytes. What massive advantage you got? Nothing. In most cases, search
okay.
queries are small, right? So it does not make sense to store references everywhere. So what you store is you store the actual search query. Let's say you give example of
Okay.
Justin Bieber, and there is no harm in that. And let's say you have India versus Australia and something like this. You store 10 strings.
Okay.
But only 10 strings would you store because you are serving recent searches.
It's kind of like on the for the search bar, we only need these many searches. And let's just say like if we are doing it in a relational DB, we can have some sort of like a history type of structure, which can provide like which can keep more of the searches if we want. Like there is an option in Google, right, which shows us all the searches that have we made in the past, actually, from what I remember.
Okay, but you're still not clear in your head what you're actually trying to do. Think, take your time, pause, take a pause, think about it. Don't go into
Sure.
you need bit of clarity, because just because some other platform have it does not mean you want to build it. Stick to the requirements that we have, right? And build a good system around this requirement, right?
Sure.
But thinking of extensibility, like you brought up good points, but always have clarity in mind. Like, for example, the point where you are making search ID sort of stuff is totally random. Don't do that. It's an overkill, right? Because what you are optimizing, you only said that it's very heavily utilized service, 50% of user tapping on the search bar, seeing the recent searches. It clearly shows that it's very heavily utilized. And then you are making a network call. You just countered your own argument, right? So think on those lines as soon as possible and keep those things clear in your head. But I'll pick 3 of your points and add it to this design, and we'll basically cover that. Okay.
Sure.
Let me pull in Hemant. Hemant, what this, like, will you store only 10 searches here or more than that?
Okay, maybe I will take from it is one step back. So what we need as soon as somebody taps on the search bar, a request goes to server definitely. And for let's say the user ID is given. Now you are supposed to get the top 10 values saved for
most recent 10.
Top
most recent 10.
Recent, sorry, my bad. The recent 10, how now you will say recent 10. That's the representation I need to kind of have in my backend, where for each of the search word or search phrase, I need to have the visited frequency last time when it was
visited type, like search time,
search
frequency
search
time.
Yeah, sorry, search time. So we need that timestamp which talks about this was my last. Without this, I will not be able to modify it. So let's say top 10 search were there. I did
got it.
2 more search for one of the item which was, let's say it was not there. Then that should be added on top of it. So what it needs is a minimum timestamp to save this, and this has to be sorted on reverse timestamp. I mean, latest at the top, because we are saying recent. So what I need is definitely the timestamp sorted in a latest at top. So this data is the minimum which I required it. So these are the values I need to save.
So the list that you are storing, how many items does it contain?
Okay, that's the next important thing that we have to think, because it's not directly you can say 10 in my opinion, because as soon as a request comes for each search that user does, you have to go and update this database. because we are talking recent. So let's say I have a list of A to A, B, C, D, something like this. Now I search X last. Then I need to go and remove the bottom item in this, when I say recent, and put it in a top. So from that perspective, it looks we should have these 10 values saved in user ID. And this has to be definitely persisted so that all, I mean, we were talking about the cross device consistency. So if I did a one search, I should have saved it, because the next call from another device should be able to give me the latest one. So that's the next thing that has to be there. Now, so what I'm thinking from the perspective of how this data is represented, how this is modified. Only two things. We are when I say delete, delete will be like a modification. You did a recent. Now, one more thing which I'm trying to comprehend is, let's say somebody tries to search the same word 10 times.
Wait, before jumping onto that, first let's convert. That's a good edge case you're talking about. I want to talk about it, but now let's start with this, because we're still not conversed on how we are storing the data, right? Okay, so first of all, you spoke about modification. That's important because you would want to keep it sorted with most recent item first and whatnot, right? So now let's go into, now that you have carved out a lot of details, what exactly will you store and where exactly will you store? First question, I'll start putting the question, and then you help me answer that. Will you have a persistent data storage to store all the recent searches made by the user? Yes or no?
Yes.
You need persistent, right?
Yes, I need
persistent. Okay. You need persistent. Okay. Now, will the persistent storage contain all the searches, not just last 10, all the searches made by the user ever? Yes or no?
Okay, I was trying to think this thing. I couldn't come up to an answer because I have a different view. Okay, so I can talk about the thought process because I couldn't conclude it.
No, but okay, speak about it. Will you store all the searches made by all the users ever?
No, that is not required.
Why not?
Because what we are looking for only recent. 10. Recent 10. We have two things. We have recent and we have 10. I'm not going to tell user that what was your history of search. So there is when we talk about history.
So you are not telling user, but if you are not storing anywhere, which means you would not have data about all the searches ever made in your system.
Yeah, so that I have not seen in the requirement. If we need somewhere in the history, then I need the way that we are designing the current system. It doesn't talk about that I need the history. I need only 10.
Thanks, Hemant for not going in that other direction. Okay, let me talk about it. Right. Thanks so much. I'll just pull you in 1 minute. And so what Hemant said is, he would, given that the requirement did not specify that we need to store all the searches of the user, I would just store and it says that, hey, I would only be rendering the last 10 searches made by the user. I will only be storing that much. This is where lies the difference. When you get a requirement from a CXO, they are never laid out. Then they don't consider all possible cases. For example, if you do not store all the searches ever made on your platform in a flow like this, what does this mean? That you don't know how your user is behaving, or sorry, how your user is interacting with your system. I'll give an example. So search bar is one of the most amazing places for a product to get feedback or to get ideas about it. I'll give an example. Let's say you are building Udemy. On Udemy search bar, people search for, let's say, Hussain Nasser. Assume that Hussain Nasser at this moment does not have any course on Udemy. People are coming on Udemy and typing Hussain Nasser. They would see 0 search results found, because up until now, there are no courses of his. Assume that. And now what you can do, as Udemy, you would see, hey, which are the search queries that resulted in 0 results? This would be that idea. Hey, if a lot of people are searching for Hussain Nasser, it might be a good idea if we bring him as an educator on our platform. Another example, let's say if a lot of people are searching on Udemy called database engineering in Hindi, and a lot of searches are made on that, and with almost very poor quality results because there does not exist any courses in Hindi yet. What you as a Udemy team can do, you can figure out, hey, there is a gap that people want a database engineering course in Hindi. Let us onboard educators who do that. So search bar is a very good place for you to get these sort of insights on what next for your platform. So no matter what, although this requirement, what I just said, and I deliberately have not mentioned it over here, is because that if you do not store all the searches made by all the users ever on your platform, you would not be able to gain those insights, number one. Number two, in case your CXOs says, hey, Arpit, can you share some history of what this or what people are searching and how we can use it? You say, I don't have that. I'm just storing the last researches. Your CXO would say it's a no-brainer. You should have done it. Data is very important. Now we don't know how people are interacting with the system, right? So you as a senior engineer, you need to read between the lines and see what all things are essential for your business. Product is fine for your business. This is directly impacting the revenue because now you can bring in, you can suggest things to your content team, to your business team to get these sort of educators, these sort of things. And that's what makes the difference. Don't just limit yourself to code. Think of how you can grow the business. And to be honest, that has been one of my biggest learning ever. I always thought of building systems like a pure laid out plan. It's never like that. As senior engineers, you should always, and it's not that, and like as senior engineers, you should know how to read between the lines. And one of the faint things that are between these lines is exactly that you should store all the historical searches made by the user, even though the sketchy sketch that your CXO made had only last and recent searches, right? So although you would be optimizing your system to serve the last and recent searches, but it does not mean that you should not store other searches made by the user, right? So these are the things that always keep things in mind, that not everything will be chalked down to the most granular detail ever, especially when it comes from a senior management like CXOs and VPs and maybe even a senior director. They would just say like 2 or 3 things. They hire you to figure the other things out and make system as better as possible, right? Okay, so what we know is we want to store all search queries but optimize for 10 recent searches. Okay, Hemant, just want to pull you in for your thoughts on this part, that if I were to store, I'll pick you for the first one. If I were to store all the search queries, how would you store it?
Okay. We have to first think about the schema, as we always do. That there is a text that you are being searched. You may also look about few other things, which is like what is the timestamp, and even so I will give maybe a bit stressed way of thinking that the queries that we are searching, as it is, each and every query that is coming, we can save as it is, or we can so normally people try to search something which is not like the right spelling. Okay, we'll say
that is it. So you are assume that those queries are there, like raw queries you need to store somewhere, right?
Yeah,
these were the, because so that you can improve other systems, which we'll talk about in the third system we'll discuss today, right?
Yeah.
But assume whatever query, the raw input coming from your user, you need to store them as is.
Okay.
Right?
Then I'm assuming that we are just thinking about kind of a ledger where each and every query is being appended in the system as soon as it comes with the content. I mean, like query timestamp and who did that search. Maybe also the device identifier or other
Correct.
thing.
All other thing. Elaborate.
Yeah. So when the searches are done, there are two ways that you do the search. You either choose it from the recent or choose it from the by typing. So search can be done. As I said, we show the 10%. Okay. Once I write A, you immediately you without auto suggest, I'm talking, we are simply saying that these are the 10. I will not think about of anything and select which I want. That's the way of searching.
What are you storing? Why are you digressing? What you are storing? You're talking about browser and device and whatnot. What are you storing on disk?
Disk is device ID.
Just device ID.
Device ID to identify which browser. I mean, how you can have a separate schema which talks about this device is this type, this region, and all those things. What I'm saying, identifier for device has to be.
But that's not. But you need to be very elaborate when you store this on your disk, right?
Yeah. Well, my idea was I need a unique device identifier within this thing, and maybe another.
But then doing analytics with these two sets of data becomes difficult. So you typically denormalize and store it together.
Yeah. If we are okay with the denormalization for now, we can put everything, and that's why another thing which is like typed query or taken from the sent can be another thing which is very important.
Yeah, that we'll talk about. We get to cover that. It's just 1% of what we are discussing about till now, right? Okay. Thanks so much, Hemant, for adding that. Now here, one key thing that I want all of you to think about is because no one told us to capture this information, but CXOs will expect you to do this to help your insights team do this crunching. Inside, you can't say, no, I'm not storing this data. That's when I'm stressing this point so much that think of possible extensions to your system. Think of possible things that would help you build a better business. Always. Business comes first. Engineering is the last thing people worry about. Trust me on that when I say this. Engineering is the last thing that companies would worry about. You have seen now what is happening with AI. No one's caring about engineering. Everyone just trying to add things to product and make business out of it, right? Everyone's doing that. It's all about business, no matter what. So if you are an engineer and not thinking about business, that's wrong. As an engineer, also junior engineer, senior engineer, the sooner you think, the better it is. Always think about business, then product, then engineering. When you grow in your career, you will realize that this is the harsh reality, right? Okay. So given this data that you are storing, Gaurav, I'll pull you in. How will you store this data? My options, I'll give you options. Option 1, will you store for each user? Now I'm talking about storing all the searches made by the user ever, right? On this storage. So will you store this? So there are two ways to store this data. You store user ID, against which you store list of queries made by this into one document, something like this. Or second way to store this is you store individual document one after another, having user ID, search query, device, region, and whatnot. Which one would you pick to store all the searches made by all the users ever?
I would go with the first one because that seems faster. The access time for that seems faster.
No, but we are storing all the search queries made by all the user ever.
Yeah. So
if I've made up until now 10,000 searches on Google, will I be having 10,000 entries over here?
So how will that be stored in second case then?
Individual row, like on MongoDB. How do you store in MongoDB? Individual documents, right?
Yeah.
So these are individual documents, like an Elasticsearch.
Okay. So for the first case, yes, we can have 10,000 entries for each search. However, what we can do is something like compaction, if I'm not overkilling the problem.
You are.
Once.
Why?
No.
Why would you want to keep because this would bloat your single document, won't it? Because now you have in each entry of this, you have this much of data and you have 10,000 such entries for every user. And I'm being very conservative when I say 10,000, you make at least hundreds of searches on Google every day, right? If I just crunch some numbers, if you make hundreds of searches every day, in a month, you would make into 30 searches. Each search document would have at least 1 KB of overhead, right? Now, which means each month, one user is creating 3,000 into 1 KB, which is equal to 3 MB of data per user per month. 3 MB data per user per month. There are 100 million users into 3 MB. It becomes 300 GB, right? Or more than that. No, more than that. 3 TB data, right? MB is 3030. 300 TB data, not worth it, right? So this means that amount of data, like the bloating that you are doing over here in one document is huge, which is where I would want to break to all of your notice is the concept of bounded data and unbounded data. So typically you never store. What I mean when I say bounded data, it means you exactly know how many items would be there in a list that is bounded. When I say unbounded, it means the data would keep on coming and you keep on growing it. For example, for us to store all the queries made by the user, we have 2 ways to do it. This way, where you store key is user and value is list of all the queries made by the user ever. But how many would be there? It is unbounded because user will keep on using the system, will keep on firing search queries. Now this list would have starting with, like, let's say 10 items it started with, then 20, then 30, then 50, then 100, then 1,000, then 100,000, then 500,000. This would keep on growing, right? And every time when you do an IO operation on a data like this, the way typically lists are stored, it would have to, your database engine would have to pick that entire list, add something to it, serialize it, and then store it. So it is never recommended to store unbounded data in a format like this. Whenever your data is continuously growing, think of it in storing like this. Each search query is its own individual document. This is unbounded data, right? So when you are storing, now this also tells us that when you are just storing, if you know that your list would only contain exactly 10 elements, no matter how big those elements are, in our case, it would be 1 KB each, roughly, right? Even if you're storing, if you know that there are only 10 elements that we would store ever in this list, it's bounded. You can think of keeping it like this. But if it is unbounded, where it is, go on mute. But where it is unbounded and when it continuously grows, this is not a good way to store the data, which is where you should always do like this, right? Where each search query in itself is a new document that you're putting. An analogy for that, MongoDB list versus MongoDB individual documents. So when you know that you would be storing exactly 10 no matter what, this would work just fine. When you know that your data is unbounded, you should typically go like this, right? So this is one of the most important design decisions that we would need to make, because if you go with this part, your document would be bloated up because now each document contains a list containing ever-growing number of elements. That is problematic because then that would bloat up your document size to a huge percent, right? You don't want that to happen. So now we would need to know how we are storing this data. So I'll just quickly write that part. So now that we know that, first of all, we are storing all search queries made by all the users ever, right? Now that needs to be stored somewhere. All the search queries made by every user ever on a persistent storage. And now this, you can use any document database, MongoDB, Elasticsearch, anything is fine, right? But where you are storing all the searches made by all the users ever. And that, why we are picking that? Because we want partitioning, because we saw the amount of data that we would be storing. OneNote will not be able to handle that. And there will be like literally every search query made on your system is equal to one document on this disk, which means that this needs to be a well-partitioned data where you would be partitioning your queries or partitioning your data on the basis of user ID, right? And each document and each thing will be a document. And this is a classic case of and unbounded data. Okay. Now here you can actually very clearly see that this is where you can store data like this. For every query, you are storing the data in a very detailed fashion. That hey, this was the search query made at this time by this user from this device with this OS with this browser on this region. And you would have each document containing very detailed information over here. And now you can also clearly see that the data is unbounded. How likely are you to access data which is 1 year old? Not very. So what you can do is you can archive this data on S3. Because why to have bloated cost on your infrastructure? Just archive the data to S3. So all the search queries made by all the users ever will be stored in any document-based database. Let me give a concrete example. Let's say MongoDB or Elasticsearch. Anything is fine, or even any other database for that matter. Even BigQuery, but not as a transactional thing. Semi-transactional thing, you would do that. That goes over here. Then an archival job kicks in, which keeps on deleting the historical data. Let's say you define that, hey, I would not store 6 months or data older than 6 months over here, so that you keep the infrastructure cost down, right? You take the data which is older than 6 months and archive it on S3. This would help you keep the cost of the system down, right? Okay. Now, when we write to this database, we have two choices: either write synchronous or write asynchronous. Right? Given the amount of search queries that are coming onto the platform, because every time user searches something, we are making an entry into this database. Right? When you type any query and hit enter, that search query is registered in this database every time. So making a synchronous call on this DB would overwhelm the database. So you need to do it in a staggered way. Batch ingestion and batching is one of the most common optimization thing that you should think about. So what you do, you would want to batch the request and write it in one shot in this DB, right? So how do you do it? For every search query that happens onto your system, you put those things in Kafka and then consume it from there and write it over there, right? So here what you do, or rather you would have one more thing, but yeah, that's given, but still let me be explicit about it. So it writes over here, and one of the key things that you will do is here you would do batch ingestion. So whenever your user is firing any search query ever in your system, this is your search service where your search query is coming in. Right? Now search service puts that query, gets all this information from the request headers, compiles it into a message, puts it into this Kafka. Kafka high throughput ingestion, it would just accept the writes, right? Then the consumers of that Kafka would read messages from those corresponding partitions, batch them, and ingest them into this database. So here you are doing batch ingestion. So you are not writing one query at a time on this database that would overwhelm this database, but you are doing a batch write over here. Here you would still write, you can still batch over here if you're okay to lose some data. But worst case, even if you write one query at a time on this Kafka, it's still fine. But here, when you write it to the database, do it in a batch fashion. This way, we now have all the search queries made by all the users ever on this system, ever. And then which is periodically archived onto S3 to reduce the cost of our infrastructure. Right? So up until now, what we have a place where we are putting all the search queries made by all the users ever. Now what we need to do is now we just need to serve this, right? That let's say this is your /search endpoint, whose job is whenever user is searching something, that search query is added there. And obviously your search engine would be using Elasticsearch or any other search engine, Elasticsearch to power it. So now this is your search service. Now let me just first converge on this flow, then we'll forget the other discussion. So when a user is actually typing something and searching, right? You typed a query on Google and searched it. Google gives you search results. So when you type a search query, the query comes over here. Search engine goes to Elasticsearch to find the most relevant documents and whatnot. it compiles a message, extracts the information and puts it over here. What information? Like user ID, device, OS, browser, region, that is ingested in Kafka. And your search service returns the result to your user. That, hey, these are the relevant documents for that. These are actual search, right? Now from this Kafka, the search queries are batch ingested into this database. This could be MongoDB, very simple database to use for this purpose. And any data which is older than 6 months can be archived to S3 because you don't keep more than 6 months, but 6 months, 1 year, 2 years, product call, right? How long do you want to keep data over here and how long before you can archive it to S3, right? So this is your flow where you are now storing all the search queries made by all the users ever. Now let's go into recent searches. That now what you want to do is you want to serve recent searches made by the user. Now here the thing is that you would have a separate endpoint to do that. For example, /search/recent, whose job is to give you the last 10 recent searches made by you. And now what would that flow look like? Anubhav?
So either we have to serve the top 10 recent searches from some servers, and the way to do it
That
would be,
came over here. Then
yeah, either we can maintain a list of top 10 recent searches here, and whenever new searches are made, we then write it back to the search DB.
but we have this now, where we are storing all the searches made by all the users ever.
But querying that for top 10 searches would be
Not top 10, recent searches. This will anyway be ordered by time, right? You can just have an index on time and have it sorted, right? That's not a concern. Can you not make a query on this? Here you have for all the users, all the receipts are all the searches made by all the users. Can you not get most recent 10? It's not even top 10. You don't have to do any aggregation. It's just most recent 10.
I'm thinking if it would lead to for some users, like I know we've partitioned on user ID, but our partition could be even more granular at times. So if it would lead to cross partition queries is what I'm
You would
thinking.
never have to do cross partition. You are anyway partitioning by user ID. You have your data. Just keep an index that is ordering those things by time, or may have your main database itself ordered it by time and store. Can you not just use this database to store that information to get the recent 10 search queries?
From a source of truth perspective, this is a source of truth, but I still
Perfect.
feel with putting extra load on this database can be avoided.
Why is this an extra load?
Because we are already writing a lot, like for this database, we are already writing a lot of batch queries to all the search history of all the users for all the time. That write load is already there on this DB. So I'm thinking if we can separate out the read load for the top recent searches, we can reduce it.
Why fetching recent queries is a read load, is a high read load for this database?
Because our users, like I think 30% into 50%.
Exactly.
So many users.
Right. This shows you that the amount, it's not a write, like this is where we are taking care of high writes, but this might not be a good place to do reads for that matter. Okay, that's one point, that our use case is read heavy, but why would this be a high read load on this database? Not just because of these numbers, think of other reasons as well. Why would this be a little inconvenient for this database? While it is doing all the writes, accepting all the writes of all the queries that has happened, why serving reads of a user become a problem? Like when it's high read load, when you're putting onto this database. Databases are typically pretty optimized for read loads, right? Yeah, go on.
Even if we have an index, I think with frequent writes, the indexes will need to be rebalanced from time to time. So that will cause some delays in some queries. Like
your writes are slow when you have an index, correct?
And indexes will be rebalanced. So while the since this is a high read throughput system, while the rebalancing is done, our reads will be also very slow for that. So that is one reason which I can think of.
That's a good point. That's a good point.
What else? What else is so apart from
No,
index?
that's okay. You brought up some really good points. You thought about index rebalancing. You thought about you paying the cost to keep data sorted by time, right?
Yeah.
You're paying cost for that by creating an index on timestamp.
Yes.
Right? When you create an index, now when you write to this database, there will be two writes, one on the data and one on the index. Right?
Yeah.
So you are taking a hit on your write latencies on your database, because now you are writing on the data and in the index. Your database implicitly does that, but still your writes would be slower. So we might do something better over here. Given that search is a very high throughput service, whichever product you use, if you give a search bar to your user, a user is very likely to use that, right? And given that it's a lot of queries would be fired on this system, so you need very high write throughput on this database also. Whenever you are doing batch ingestion,
Yes.
what index are you creating? Is there a need to keep data sorted in some fashion, and whatnot should be your key points that you are thinking about, right? But you brought up some really good points, Anubhav. Thanks for that.
I want to just add like one.
Please go ahead.
So from what I understand, the major purpose of this source of truth database, apart from obviously hydrating our top 10 services, analytics. So do we really even need an index here is one thing which we can think about. Like if we write as our performance requirement is there.
Yeah. Okay, that's also a great point. But again, this goes for everyone. It might look like, hey, we are not going anywhere or we are not converging on something, but all these points, all these factors that we are discussing are very important, because a lot of people don't even think about this, that how writes are happening. I'll just create an index. But having an index is also pain. Index requires special storage. Index requires you to do writes at multiple places, right? So it's not that for all systems this will hold true. For some very high throughput search systems, it would hold true. But you need to know the potential pros and cons for every single design decision that you are making. This way, you can fit your system into a very nice plate and serve it for a very good use case. Right? Okay, Nitin, will you read from this database to serve recent searches of the users?
I mean, so far, so when I raised the hand, the discussion was going on at some other point, but right now, so converging on all the points raised by two other folks, so it doesn't seem a good option to have a read from DV. Maybe we can,
Why? Why?
As there are a lot of batch operations being happened. So earlier I was thinking like having some kind of combo index of user ID underscore timestamp, so that the 10 recent searches would be read from the DB directly. But then I also thought from the user perspective, when a user clicks on search bar, the recent searches should be very quickly populated, because they start typing the new search. Okay, so that should be very minimal. That the time to load should be very minimal, and so reading from DB seems kind of like higher latency.
It seems slow, right? But it might not be true always, but it seems slow at the moment.
Correct.
Okay.
Maybe we can implement a cache. Implement a Redis over here that will only maintain a list of 10 recent searches of a particular user ID in LRU format. LRU eviction policy for a user. Okay.
You would have to manually manage that. Like LRU algorithm would not kick in. You would have to manually manage it. But that's fine. But before that, let's be very sure on why you are suggesting to add Redis. Let's be very sure on that, right? So what would happen if you are reading, like first of all, you all agree that this is a very high write heavy thing because search is by definition itself, it's very high throughput service, right? So when you're writing over here, and if you have an index, now your database would have to write it two places. So can you drop an index, Nitin? In order to ensure high write ingestion, if you don't have an index, it means it doesn't have to keep store data in a certain way, in a certain organized way. That would give you a better write throughput, correct?
But then the reach would be some kind of slow because we need to get the top 10 recent searches in the descending manner.
Correct.
So if we don't maintain a time index on timestamp, then how would we fetch it and sort it?
Exactly. Exactly. So now here you see a trade-off where
Yes.
either you bear the cost of maintaining an index on per user timestamp basis so that you can quickly get the most recent 10 or 100, whatever you are looking for from this database, right? Otherwise, if you are going for very high optimization of write throughput, where you can make your read slower, you drop this index, which means this would make this database as log structure database. You just continuously keep on appending one after another, which would make your read slower, right? That's a trade-off. That's a trade-off that we would need to make. Either this or that, right?
But
Which
we
one would
need-
you pick? Go on, Nitin.
But we need a lower latency in reads. If the writes are
But then your ready solution solves read latency problem.
yes. I mean that's a different direction. Let's dive a little bit deeper in this, and then we can think of that direction. Another point I was thinking was, I mean, having an index on user ID and timestamp combo index, whether that would make the writes slower or not. So let's say, so we have an index on user ID and timestamp, and let's say some other users, some other n users are, data has been is going to be written in the DB. So the memory space of that index, I don't know, like the internals of the index properly. So writing some other users' data, will that affect the optimization of the current user? Like,
Not really,
like
but your database CPU would still be consumed into figuring out where to write, and then disk I would be consumed to write it there. That would be there. That would be there. It would
that
not
really
affect the correctness, but throughput definitely yes.
Okay. So yeah, I mean, while doing so, if this is the thing, then we can think in the direction of having a cache kind of system, Redis kind of Redis system for maintaining the top 10 recent searches. And while batch processing, we have to do the insertion, deletion, whatever operation we need to do to maintain the cache. Because over here, if you think from the user UI perspective, whenever we click on the search box, we quickly get the recent searches.
Correct.
Over there, we don't have to hamper the user experience. So we have to take this trade-off.
Correct. Okay. You brought up a really good point that user experience is very important. And the reason to back it is that if 50% of users tap on the search bar within first 5 seconds and if they see loading icon there, that's a very poor user experience. You want to search this as fast as possible, right? Okay. So that's an important point. Now, let's just spend a little more time on this part because this is a very interesting discussion. First time we are forking this discussion in this. I never covered it, which is I love this batch. You folks are going in such interesting directions now. It's so fun discussing stuff with you all. Okay, but one thing that I'd still want to spend more time on this database itself, the way we are storing it. Now, let's say I take this route and let me just infuse something so that we think on this direction. That what if assume at this stage that search queries is very high throughput thing, right? Someone's not on mute, please go on mute. It's bugging me. And it would come in the recording. Thanks. Okay, so where were we? Okay, so now here at this stage, what we are having is assume that the search queries that are coming in, they're very high throughput service. And in any case, search is almost always high throughput. And so which means that when you're writing to this database, if you have a bunch of indexes on this database, that would make your write slow. Let's say, hypothetically, I am optimizing for very high write throughput. Hypothetically, right? Which means that I will not have any index on this database. Any index on this database, which means that what my batch ingestion would do is whenever it is writing to my database, it is always appending at the end of the collection. Always. There is no sortedness, no order that it is maintaining at all. Right? So whatever your batch ingestion does, or it reads from the Kafka, it immediately flushes it to this database in a log structured format, which is one after another, one after another. So you are not following any order per se. The order in which your writes are coming is the order in which it is getting stored. You may be getting like on this, there is no particular order that is order by timestamp or order by user ID and whatnot. It could be in any order. Now, what this makes it interesting is we are optimizing this subsystem to be very high write ingestion heavy subsystem. And no matter at which load the search queries keep on coming, I would be appending it to this database one after another. Which means that we are optimizing this part for writes, which means your reads would be slower. If our reads are slower, but what we want to do is we want to serve very fast reads to your user, because 50% of user will tap on the search bar. As soon as they tap on the search bar, they would see the recent searches. They want to see them as fast as possible. So given that, what we need to do is, given that this system cannot give us very high read, or rather very fast reads, given that we are optimizing this for writes. Any database can be either optimized for reads or writes. Here, we made a deliberate choice of making this optimized for writes. Now, for us to do reads, what Nitin suggested is to add another component that would take care of reads. Right? And what he said, let's use Redis for that. Okay, let's go with this decision. Right? Let's go with this decision where we are optimizing this for write ingestion, these for read heavy operation. So now your recent searches of your users are coming from here. Right? So the thing is, one very interesting thing. Now things starts to become really interesting. That when a user makes a search query, oh sorry, I should use a different color. Sorry. This over here and this is Redis. Okay. Now, when a user makes a search request, it goes to Elasticsearch. The data is captured about that request, put into Kafka, consumers consume it, batch ingest it into this document-based database, and which is optimized for writes, which is archived periodically and dumped onto S3. Right? This is the flow that happened. Now we want to think of optimizing the system for reads for end user experience. For end user experience, what we think is whenever user is searching for recent searches, the request comes to this Redis, gets the data and sends it back. Right? Now this is where some interesting challenges come in. How will this Redis get the data? Let's start with that. I'll pull in Siddesh. Siddesh, go on. And basically Rahul and Hemant, because you folks spoke, I'm just giving other folks a chance and more than happy to pick you up. Right? Okay, go on, Siddesh.
Yeah, Arpit. Yeah, one way is we do two writes to Kafka and Redis, which I don't think is a great way. The reason
you're
is
doing two writes to one to Kafka and one to Redis.
Yeah, the reason is, which I don't think is the great way, because our heavy throughput system, and maybe we are unnecessarily maintaining one of those. It's a good start to add a cache, but maybe we can replace one of them. So one thing I can suggest is we can add a persistent cache there.
Redis is a persistent cache. If you configure, if you basically configure an AOF thing, that solves your problem.
Yeah. If you consider that, I was considering it as an in-memory cache.
Yeah, it is in memory. It is in memory, but it can periodically persist data to disk.
Yeah. So if we are okay with that consistency, then we can only write to Redis. Basically, I'm proposing that we
Mm.
can get rid of Kafka.
Okay. So then how would that data come over here, batch ingestion and all?
Basically, whenever Redis persists those files, now the same thing that happens, the batch ingestion is doing, we can persist, like read those persisted files, like design a pipeline there, which will then ingest in batches to databases anyways.
But Redis requires you to store everything in memory. Imagine such high throughput only writing to Redis, so many queries being written onto Redis. Not a good idea.
Yeah, I was thinking of eviction too. We don't want to store everything in Redis.
But then how are you evicting?
Like eviction is basically here, what you need. Let us suppose n recent searches. So anyways, the data that I am storing is per user, per recent searches.
Okay.
So the eviction.
Let's decide on schema. How are you storing data? What is the key in your Redis?
Let us suppose the key in the Redis is user ID.
Okay. And the value?
User ID and timestamp. I'll basically do a join of both of them to create the key for that. And then the value is everything that we want to append to the persistent database.
Okay, got it. Okay, if you are storing it this way, one challenge that would come in is how will you render recent searches for a user?
Yeah, I was thinking we can do a persistent thing, or anyways we can do. I am not sure.
This is exactly why, right? So if your reason, and by the way, thanks for bringing that up again, because this teaches us a lot of stuff. That, for example, if we added cache, now let's say at this moment we keep Kafka as is, right? We write at two places. Now, if this, and then we would obviously optimize that going forward. But if let's say at this moment we have Redis, because we have added Redis to improve the read performance of our system, that whenever user is searching for recent, or where user is doing a recent search, that would come to this Redis to get the data. We have to structure this data such that it is highly optimal for us to just read and send. Nothing more, nothing less. So the best way for us to represent this would be your key becomes user ID and the value becomes exactly 10 recent searches made by the user. Exact 10 recent searches made by the user. No more, no less. Right? Oh, sorry, less can be possible, but no more than 10. This way, whenever user comes and taps on the search bar, we directly make an API call, get the data and send it back. Right? This is not a classic cache implementation that, hey, if this goes on, it will go to the database and read it. Which is where now my next question comes in, and I'll pull in Amrita, and then I'll basically circle back to you, Rahul, for that. Amrita, I have a question for you. That given that our Redis has user ID as the key and the value is 10 recent searches, can you consolidate on the write flow that we now have? And then I'll ask my question. How does a write flow look like? Which means when user searches for a search query, then what happens?
So Arpit, basically I was taking hint on first thing that the search results have to be within 5 seconds. And also we might like stale data can be provided in certain cases. So what we can do is that we can use the write through cache kind of mechanism where for a certain period of time, we can keep writing to our Redis cache and we will keep updating the results there and we'll flush it to the database after that periodic time.
No. Kafka is here. Kafka is not going anywhere. So your search service writes at two places now.
Okay.
Right? At Kafka and on Redis. Now what's the flow, like what the flow would look like now? Search, let me answer that. Let me then ask you a very pointed question. So when a user searches for something, it comes to searches something as in a search query, actual search query, not recent searches. When user searches for something, Elasticsearch, get the result, put an event onto Kafka, batch ingested to this database and whatnot. But search query, apart from writing to Kafka, your search service also updates the Redis that, hey, this is the recent search, or this is the most recent search made by the user just now. So in that case, what would happen is it would be prepended to this list. The new search query that the user just made is prepended to this list. And every time the user makes a search query, this thing is prepended to this list every time. Right? And then we just check if this list is more than 10. So then remove one element from this list. This way we maintain this Redis to have exactly 10 elements in this list. Right? Okay, Amrita, do you see any problem with this approach?
Yes, we are having two different mechanisms to write. So we have to keep updating data in the Redis, and as well as we are pushing it into
So you have to put in Kafka also and Redis also. But why is that why is that a very big problem?
It will introduce, so it will need some compute time, like we are processing the data twice.
This is okay,
And
right? This is just a Redis. Redis hardly 2 milliseconds, it would be done.
And also, since we are writing at two endpoints simultaneously, we might have some consistency issues.
Like,
So we are writing to Kafka and Redis. So timestamp, maintaining timestamp might be an
no, you
issue
can
there.
maintain timestamp over here. You can write the same timestamp over, and here anyways, you are not maintaining timestamp at all, right?
Yeah.
Because you are just literally storing the raw search queries that you would be rendering this interface on.
Like the
Right? Not a problem.
like it, we might not get recent results.
We would get recent results because we are prepending to this list, always inserting at index 0.
Okay. Like we might. So since in Redis is going to be updated instantly, and writing through Kafka will take some time. So if the Redis fails and if we try to fetch results from the database,
Exactly.
the
Why?
results won't be seen.
Now my question is why? Now you brought up this point that here I have no connection to this. Now if Redis fails, what would happen when Redis fails? You think about data loss?
Yes.
You configure Redis in persistent mode. It would keep dumping data onto the disk. There is no failure. So even if there is failure, you would be able to reconstruct that entire thing, entire Redis when your machine reboots. It's not that if Redis is down, you have to go to the database and fetch it out. Key does not exist in Redis. That's not here. Redis is not a cache. Redis is actually a storage mechanism for us to have fast reads.
Okay.
So with this persistence, it solves the problem that even if this Redis node goes down, we are not losing any data. When this node comes back up, it would just load that same file and rebuild everything, like rebuild the entire data in memory.
But we'll have some downtime there.
Downtime to if it was your component is down, then you'll have downtime. Nah. That's okay.
Yeah, I probably don't have answer.
Yeah. So see, these are the things I want all of you to think about and prove yourself. What would happen? Because this already exists. So persistence on Redis is a solved problem so long as you can fit the entire data in memory. Right? And the point that you brought out was around write through cache, that you write through the cache and then you periodically flush it to the disk and onto your main database. How would you implement it? When you think about implementation, you would not go with that approach. Right? You would try to keep things simple. Right? Okay. But at least everyone does agree on this fact that having this makes sense for us to have very fast reads. Now, for us to have this very fast reads, we are doing this. And here, what we are taking a hit on is your search service now have to write at two different places, one on Kafka, one on Redis. Now, this Redis needs to be done in real time so that whenever the next request comes in, it is like updated over here. It's not that Redis would go down, I would go to the database and read it, because our database is not made for reads. We just dropped the index that would store it. We are making it very optimized for high write ingestion. Given that it is optimized for high write ingestion, for us to get the most recent 10 searches by the user, it's not very easy query for this database. So that is why we have to make this other database to be the source of truth. That's why we are configuring it in a persistent mode. AOF persistence you can go with. Append only file AOF stands for that, right? But what we have to do now is we have to maintain 2 copies, like 2 writes, one on Kafka and one on Redis. A way to solve this problem is instead of your search service writing to Kafka directly, you may choose to write it from this consumer. Unnecessary kill, would not recommend that, but in case you want to do that, you can do that. But I'll just fork out a couple of terms for you. Transaction outbox pattern. Maybe you can go with right. Think about implementation at every place, right through cache. But I would keep things simple. Even if there is 1 or 2 data loss, it's still not a big loss for my system. Right? If you think about it, which one do you write first determines a lot of things for you. Right? For you, when you get a search query on the search service, when you write it to Kafka or you write it to Redis, do you really need a very strongly consistent system, which ensures that the write has gone to both the places or none? I don't think so. Because search is a very high volume service. Even if you miss out on a couple of queries, not a big deal. Exactly what I'm saying is you don't need strong consistency in every system. When you're building realistic systems, you know when it is okay for you to relax which constraint. Here, as an example, I'm relaxing a constraint where I don't need strong consistency across these 2. In case you need it, then your search service cannot populate this Redis. You may want to do it with this consumer, but that would make it slower to update this part, right? So then, because it takes time for this Kafka to store and then a consumer to process and then update the Redis. Instead, what you are doing is you are writing at 2 places at one time, this Redis and this Kafka. This gives you very good user experience in 99.99% cases when your infrastructure is not going down. Right? Because right at both the places will succeed, right? But in some cases where let's say it wrote at one place, but it failed to write at other, what you'll get? You'll have some query in part of Redis, but it is not persisted in this storage. But if you think about it, your user is not getting affected. You are not having that query over here, but you are not serving this data anyway to the user. User is getting served this data. So it is okay for you to miss out on the 1 or 2 query loss is fine because it's very high voluminous query, right? The amount of data is huge. Even if you lose out on few queries here and there, it's not the end of the world. You would still have enough data to make business decisions, right? And given that we are not serving this data to your user, what user sees is what you have in Redis. Simple. Redis is the source of truth for your user. This data is source of truth for your business. And you want to store all historical queries ever made by user to make business critical decision. You store this data to give user the best experience. So what you do is what your search service should do is it should write to the cache first or to Redis first, and then the second write should go to Kafka. This way, what you ensure is worst case, user fired a search query, wrote to the Redis, but before it could write to Kafka, it crashed, which means your user still sees consistent search queries made by that user. And worst cases, I would not be storing the data into my database because I write to Kafka failed. But how many times would that happen? Almost all systems guarantee 99.99% uptime. If you are guaranteeing 99.99% uptime, which means 99.99% queries are getting stored over here. If you miss 0.01% queries, worst case, still okay. Not the end of the world because you still have other huge amount. It's more like that you have 1 petabyte of data and you are crying for 1 GB of data. Hey, I lost this 1 GB of data. That other data, huge enough, is good enough for you to make business critical decision. Right? So through this, what we touched upon is knowing when to relax a particular constraint, which is something that is end of the world for you, which part of your system is not the end of the world for you, right? Keep this thing in mind whenever you are designing any system, right? Okay. And obviously this Redis will not be a single node. group of node, and you would very clearly see that this is a bounded list. You exactly know how many items you are storing in this list. It would be exactly 10, or rather less than or equal to 10. It would never grow beyond 10. So that's why you can store it in a list rather than in a document, like individual document format. This is why I wanted to touch upon bounded data, unbounded data, latency requirement, serving stale data. Okay, we didn't touch upon, but you can now guess that we are doing is we are not serving any stale data. That's why first writes are going onto Redis and then onto Kafka, and cross-device consistency. This way, because your first write is always going to Redis, whenever the call comes to this backend server, it immediately gets the data, sends it back to the user. Everything is coming from Redis. So Redis is a source of truth for your user. This distributed storage, this distributed document storage is source of truth for your business. You are never serving this data to your user. You are only serving this data to your user. Redis is not something that would lose the data because of AOF persistence. So whenever you spin up your Redis cluster, ensure that you are configuring it in an AOF persistence. What it does is whenever the write comes to Redis, it makes an entry into the append only file. If the Redis process restarts, it would reconstruct your entire Redis in-memory structure using that AOF file. Right? And this is all what I wanted to cover as part of that. Right? Few optimizations before I take questions. And that's exactly what is written over here. This is what I was talking about. Synchronous write, asynchronous write, how we're writing, when you're writing. And we went much more detailed than what is covered in this formal thing, right? Because I love this batch. Like, you folks made me talk about this so much. I never covered this. This is the first time I'm covering it, but yeah, I'm so happy to be covering this part. I'll update the notes accordingly, maybe for the next cohort. But one thing that I wanted to talk about is this cache format. And now, up until now, the way we stored this data is our recent searches are served from Redis, and that's it, right? There is no fallback to any database. But what it means is when your user comes onto this app, right? Now, this means, first of all, it means that you are assuming that you would be storing all the queries, last recent queries for all the users in Redis. You are maintaining that. You're assuming that, right? But it's a good enough assumption that you are making that for all the users, for all the queries, or for all the users, all recent 10 queries, you are putting in Redis. If you just do a small calculation, what it is about. So if I have, let's say, if we have 10 million users, and for each user, I'm storing 10 queries for each user. So 10 queries for each user. And the size of each query is hypothetically, let's say, 16 characters on an average, right? So this will be the total storage of Redis, right? So 10 million into 10 is 100 million. 100 million into 16 is 1600 million, which is equal to 1.6 GB. Peanuts. Peanuts. So long as you can configure your Redis. Obviously, Redis is a cluster. You are not having a single node instance. But data is not a problem because it's just 1.6 GB that you are storing it on there. So you don't need any fancy system whatsoever. And this was the old system that we discussed, because with our brainstorming, we went with other way. But if you think carefully, data is not the problem for Redis anymore at all. What you are having is you are just storing this data this way. It's really simple, right? You have your write part, or this becomes a source of truth for your business. This becomes source of truth for your user. You're configuring everything in AOF mode, making things really simple, right? Every single factor, as per our brainstorming, every single factor that we played was considered, right? This system that you saw in this thing, I'll update this notes because what we designed is much better than what I covered previously, right? It has much better guarantees, much better clarity, because this was another discussion that fogged out, because of which we went on other direction. But our system is much better what we discussed, 100%, right? Okay, so I'll just quickly open this part and take questions before we go on a break. Okay, Rahul, you have a question?
So basically, like there is another way we can do reads. Basically, it involves adding a new, basically, bool column in the searches, in the entries, basically in the
Which one?
DB.
Where, which, here or here?
In the DB, main DB.
Okay,
And basically like it's a bool column, which is basically like recent. Okay. Now,
why?
like
You are having a column called is recent and you set it to true or false.
Yeah, just a second. Like,
Go on,
hear
go
me
on,
out.
go on.
So, yeah, it might sound.
No, go on, go on, go on. Because I'm just worried about indexes that you might have to create and update the data, which is why we dropped the index from this database altogether, right? To support high rate ingestion. I'm just worried about that.
So what I thought was basically, like any entry that comes through writes will have like recent equals to true. Now, like whenever the user first time fetches for the recent searches, what will happen is like we will write a query, select star from the table where user ID is this and recent search is equals to true, and then sort by and sort by some order. Okay. After that, what we will do is like let's just say we have sorted those results out, and all the unsorted results. Okay. All the results above whose position is after 10, we can set those rows as false. Now, whenever
Just one question, Rahul. When you do this, so many updates, so many things you would change. Database rebalancing. It's easy when you're firing that query, but imagine how you would do that. Your database would cry out, right? You are updating it. You would have an index on is recent equal to true. You should never do that, right? Try to do it on a high volume data. You would see how slow your query gets. Very slow.
I actually thought like for the first time it will be a heavy operation, but after that, whenever you are getting new searches, you will only sort between the 11 rows, basically 11 or 12 rows, basically.
That you can anyway, but then for even to do that, where is recent is true, you want to have an index on that, correct?
Yeah.
Indexes would make write slow. That's why we dropped index in the first place. We're making this write heavy and this read heavy, right? That's fine.
Okay,
right?
sure.
We dropped even the primary key index from that, even the timestamp index on that, right? Because we wanted very high write ingestion there. Right? Now adding that is recent equal to true and putting it there, that would slow things down. Got it?
Yeah, sure.
Right? Okay. Hemant?
Yeah. So I have maybe few different dimensions to add it so that it becomes a bit more realistic. Like we have always recent searches shown, plus also the auto suggest is available in search. So this has to go hand in hand. I would like to.
No, I won't go into that direction. Auto suggest, that's a different system altogether. People will get confused.
Okay. Right. So I do not want to go in the like how it should be. I have a kind of a question from staff kind of person, as you said. So when I'm building the system, definitely I can build an auto suggest system. Okay, separately. I can build this recent system. Now, when user start typing, okay, I have to show kind of I should be displaying him the recent also. I should be
No, we are not doing that. We are just tapping on the search bar, not typing. Tapping on the search bar shows you recent results. When you type, that auto suggest system kicks in. Auto suggest will not search within your, so we are not searching within our recent searches. That's out of scope for this, right? But in case you would want to do that, then that recent search data has to be there in your search index which powers your auto suggest system.
Okay, so that's why the point is I need to kind of plug in the auto suggest system with the recent searches.
Correct. I agree. Yeah.
So that was the one thing.
So then you need to constantly pull the data out of this database. Pull the data out, then you have to replicate this data into that other place where which powers are auto suggest. Because auto suggest would be like human query, typically powered through Elasticsearch, type-ahead search.
Yes.
Right. So you would have to take this data and put it into there. So either you consume from this Kafka and put it and keep on updating there, or you take from this database and update it there. So that is what your power your auto suggest system. Not auto suggest, but other search completion, type ahead search.
Yeah, that's why. So from type ahead,
Yeah,
I was thinking how I have to merge this. So
Yes,
understood.
Yeah.
I just want to consolidate.
No, for sure, for sure.
I'm
No,
doing the right
you
answer.
brought a
Okay.
great point. You brought a great point.
Okay. So now the second thing, which in real life is when you search it, okay, recent searches, when you write search are normally not good in terms of spelling and all those. Okay.
Sir. Spelling wala part will cover in the end. I have an entire section on it. Entire section.
Then it's okay. Because I have few things around that.
No,
That's why.
we'll definitely discuss. We'll definitely discuss. At the end, I have 30 minutes reserved for that. Right?
Okay. Then I'm done with my question. Thank you.
Sure. Thanks for that. Shreya?
I picked two things. In database, I have heard about time series database. Like the columns are sorted based on timestamp. I think Cassandra does that. So, I mean, what if we also give the read traffic to Cassandra like that, which is time based?
Cassandra by default does not sort it by time. It's not a time series database. Like for example, timescale DB is time series database or influx DB is a time series database. Cassandra, you can create an index on time and that gives you the time seriesness what you're talking about.
Okay, so it involves
But then
index,
it's an index.
anyway.
Yeah.
Okay, yeah. And the second thing is, can SQS also handle batch ingestion?
Yeah. No,
Is
so
there any
batch ingestion is
particular
in your
reason?
hand. See, batch ingestion is in your hand. How you are writing to the end, this is just a queue or a stream. However you are writing, it's up to you. However you batch and write, it's up to you. Right? So here batch ingestion is where this is batching, like this is reading multiple messages and putting them in one shot in the database. So you're doing batch writes over here by reading, let's say by reading 10 messages at one time and then writing the 10 messages in one shot. That is batch ingestion.
Okay, so I mean, there's no particular reason we selected Kafka. It could be SQS also.
Yeah, but we selected Kafka because it gives you high throughput. It gives you better throughput than SQS because Kafka is log structured, right? It gives you better throughput than SQS. Plus Kafka has higher durability at cheap cost. SQS you could go with the SQS. There is no problem in that as such. But I preferred Kafka because of high throughput. Kafka has better throughput than SQS. And this is high throughput writes, I'm assuming, given search is typically a high voluminous service. So I went with that.
Okay. And why MongoDB? Why not relational database?
The amount of data is huge. You need partitioning, sharding out of the box. Or rather, you need sharding out of the box. MongoDB manages you for that. Relational DB keeps the data in an organized way and whatever. You can still use it as a log structure. But if you want to manage it on your own, do it. Number one. Number two, if you look carefully, the schema itself, like not every query would have everything. In some cases, browser is basic, some case region is missing. So, and then tomorrow, if you're adding new thing, then in SQL and the data becomes huge, you have to run an alter table for that and querying on that and whatnot. If you're just dumping JSONs or some unstructured, kind of unstructured, or rather kind of semi-structured data, MongoDB suits better. That's why. Because now if you think about storing this, you may think of everything could be one column. One column for query, one column for timestamp, one column for user ID, one for device, one for OS. The problem with that is if let's say tomorrow I'm accepting one new attribute, how will you do it? You would want to add one more column for the new attribute that comes in. As soon as you add one column, you have to run a gigantic table migration. Given that the databases would be huge because it's storing everything forever, right? Or rather last 6 months, as we discussed. The migration will take a lot of time. Correct? Alter tables. That's why, given that the data is semi-structured, makes sense to go with, and it's literal raw JSON dumps at the moment, MongoDB would work just fine, or rather would work better than relational database. But you know how much I love relational databases. So when I pick MongoDB, it's very I've seen one of my system fail because we chose relational database. It was not for search, it was for other thing, but it was a very stupid decision I made very early, and I got learning from that. That why when you should definitely pick a document-based database.
I would like to hear that at the end. I mean, it's a big question when it comes to relational.
More than happy to talk about it. More than happy. Right?
Yeah.
Okay.
Thank you.
Sure. Yeah. Okay. We'll take a quick break. And for sure, before I upload the notes, I'll make those updates depending on the things that we discuss so that you folks don't get confused. But it's exactly what we discussed. And our design is better than what is covered. So I'll just update these notes. And from now on, I'll cover in this aspect. Again, I just love this patch. Like you folks are making me think at every single step. Okay, so let's take a quick break for 5 minutes. We'll come back at 10:40, and then we design ClickBuzz's live text commentary very realistically, like literal. How imagine you are CTO of ClickBuzz and you are designing it. What's the bare minimum cost through which you would build this system? We'll literally think on those lines. And before we go on that break, I'm just dropping you 2 links, one for testimonial, one for rating. Please leave me a testimonial. It would mean the world to me. Love to, like, it would help me spread the word across folks. Please, please, please use this break to leave me a testimonial, or otherwise do it afterwards as well. But please write me a testimonial and leave this course a rating. Let's try really hard to make it better. And obviously this batch, mind-blowingly awesome batch. And this is now like hands down, the best batch. Right. But all of this is very priceless discussions for me in any case, but it would really help if you leave your testimonial. It would help me spread out. Sure. Right. Okay. Nitin, once we come from the break, we'll start with ClickBuzz. Take your question at the end. More than happy to.
It's not a question. I just wanted to see your old system. So can you upload both the
No,
like
it's very
notes?
poor. It's very poor. You'll hate it.
Still, I mean, I want to learn that.
No, I cannot. I cannot. Right. I'll keep the notes handy in case you want to take a look, but I would refer this one as a better one out there. Right. Video I would not upload. It breaches
Not video.
It breaches
Not
the
video.
I'll keep the notes
Not,
handy.
yeah,
Notes.
I just need notes.
Yeah, notes. I'll keep it there.
Okay.
Fine.
Okay.
Sure. Thanks.
Okay.
Okay. We'll sync back at 10:40. Thanks, folks. Okay, let's start with the second half. Now what we'll do is we'll design ClickBuzz's live text commentary. So here I'll show you a demo on how that actually works, and we'll design it very realistically. Right? Okay, so ClickBuzz's live text commentary is about ClickBuzz. I'll just show the website. We'll just make it easier for everyone to understand what we are designing and why we are designing it. ClickBuzz. Okay. Arey yaar, match just ended. No, still in progress. Okay, so the match is in progress. Yeah, we won yesterday's match. Yes, very happy. Okay, so this is a match page on which you see New Zealand versus Sri Lanka the match. You see the score, and this is the text commentary we are talking about, right? So for each ball, bowler, batsman, and whatnot, what happened in that ball, this is what is written over here, right? Now observe the behavior. Observe the behavior on what's happening. If you look closely, you see the text commentary, it's getting updated. It just got updated. Someone edited. The text commentator is an actual human, maybe AI in the future, but right now it's human who is typing the comment. That comment can be updated, right? If you look closely, look at the behavior. If you look closely, you see for every ball, there is text commentary. You scroll below, then you see a button, load more commentary. And then you scroll, you're reading this commentary, historical balls. And this is the flow. This is how the product looks like. Right? Now, what we are doing is, we are just focused on for each ball, this commentary, this other meta fields and all, this is just schema, right? You can make those changes, but this is what we are more interested in. How are we building a very realistic ClickBuzz live text commentary? So the match is happening live. Hundreds and by the way, ClickBuzz is India's 8th most visited website. These folks are crazy. I'm not sure how this website is getting so much of traction, but I do watch it. I know people like me do read it. It's a weekend just went. Yeah, right. So now you see automatically this got updated. Okay, so fortunate at all. Now you see this particular comment getting updated, right? So now you see the requirement. You now see how people are interacting with the system. Users like us, we are just read-only consumers of this product, right? But there is a text commentator or a set of text commentators whose job is to write this text commentary. They update it, and pages of users automatically get refreshed, quote unquote, right? Now you see this just got updated. And I'm happy, like chala, live demonstration always works, right? Now this is what we want to build. Right? Now you would have seen the behavior and how we scrolled and what happened. This is what we are trying to build, right? And you have to build a very realistic system, very realistic, nothing fancy. Think in a very realistic way on how you would build this system. It's a real-time live text commentary for a cricket commentary website like ClickBuzz, right? Okay. The requirements for the system is just quickly sharing the screen. The requirements for the system is there would be two sets of users. One is consumer like us who are reading the commentary. One is text commentators who are writing that commentary, right? Now, user should see the live text commentary with quote unquote best user experience. And the entire architecture needs to be extremely cost efficient. You are the founder of this company. You cannot let your infrastructure cost shoot up because everyone wants to be EBITDA positive this time, right? So this architecture needs to be extremely cost effective no matter what, but you should still provide a good user experience. So how would you go about it? And there are a lot of things. So we'll brainstorm on storage, access, cost optimization, and communication. Communication is in pink because it holds a special place in this design. So let's start with that. How would you build a system? Raise your hands. I'll pull you in. We have two types of users: end user, like consumers like us, the readers, and commentators. Let's call them readers or users. And the other types are commentators for updating the commentary. How would you model the system? Raise your hands. I'll pull you in. Yes, Shreya, go on.
So this is a read heavy system. Like it's only, we can call it read only also.
Hey, just a minute. I'm not able to hear. Just a minute. Is it my problem?
Hello. Hello.
Yeah, just a minute. Hello.
Yeah, am I audible now?
Yeah. Sorry, it was my problem. Most problem. Yeah, go on.
Okay, so we can call it a read-only system. Basically, only one person is going to write it, or read heavy.
Read heavy system. Exactly. Okay, it's a read heavy system. Only one person writing.
So I'm thinking about something like a replica system where only we read heavy a database, read heavy servers on which only accept read requests, and then one master, but we also have a replica, so we are not going to something like that. And this is also like time series. So I was thinking that
You are obsessed with time series today. Okay.
I mean, I don't want all the requests to go to one database. But yeah, we
Okay.
have.
But what do you mention one database? Like, wait, let's draw this to make it very visual and clear. So let's say this is your master, and let's say you have your two replicas over here. So this is your master, this is your replica 1, this is your replica 2. There is an asynchronous replication between these, right? Now, what do you mean when you say one data? So is this master a multi-node thing or just a single node?
We can keep it single node as long as we are copying the data to read replica. So we also have a standby node.
So then if this master goes down, one of the replica can take its place, right? That's not a problem. Now think about it. What's the amount of data that you're storing in one node? Because that's what would tell you if you would want to shard your database or not, correct? The amount of data. What's the amount of data that you would be storing? For every ball. So see, let's do that number crunch, right? So let's say we store on an average, a cricket match has 300 balls. I'm talking about ODI cricket, T20 has less and Test has more. But on an average, let's say we go with ODI, right? 300 balls per inning. There are 2 innings like that, correct? 2 innings of 300 balls each. For each ball, let's say we write a commentary, which is 1000 characters, which means 1 kilobyte. Yes. Right? This is what we are writing per match. Let's say total matches that have been played are roughly, they are actually around 10,000. I think, there are around 10,000 matches, but let's do it 20,000 matches. This would give us enough headway to cover the test ka more innings and more balls and T20 ka less. So this is the amount of data that we are storing. Lifetime, right? Do that calculation for me. How much it would come out to be?
Okay, 600. Okay, so this becomes GB, so MB, and then I think
this becomes GB. So 6 2s are 12 with 30 GB.
1 point.
Oh, sorry. No, MB. This is MB, not GB. So KB. So wait, let me just redo this. So this is how much KB it is. So 2 into 3 is 600 into 20,000 into 1 KB, right? So I cut this 30 and this KB becomes MB. So 6 2s are 12 and I add 3 zeros. So many MBs, which means 12 GB. This is peanuts. Right? So one node will be able to handle the data, correct? So we know that we would definitely not have to shard because of the huge amount of data that we would need to keep. Correct. Right. So sharding we may have to do for load, like for query load, but not for data load. Right? Okay. Now let's understand query load on this system. As you very rightly said, that query load it's a very read heavy system. And only one person is writing, literally one person is writing, the text commentator. So given that only one person is writing, let's say this is our internal guy. And this internal guy will add more components to that, but only this internal guy is writing to the master. Master is taking care of it. It's just 1 writes per minute on an average. If you even compute that, it's just 1 write per minute, typically, or rather 2 writes per minute. It's not a write heavy system anyway. Because it is read heavy system, you can add as many replicas as you want. 10 replicas at relational database can easily handle. Right? So let's say you have 10 replicas to handle the read. Good enough for you to handle the load, isn't it? No matter how many users come in,
Yes.
10 replicas is good enough for you to, in case you would want to have it. Very easily you can handle that much, right? So adding replicas is not a problem for you. And given that you're not write heavy, it means replication lag, if that becomes a problem, that would also not be there, because writes are one request per one write or 2 writes per minute. That's nothing for your read replica to catch up on. So there will be almost zero replication lag, almost. So simplifies our system so much, right? This means that if a simple master replica architecture is good enough for us to sort this system out for most use cases, right? Okay.
But something there is, why not cache then? Why not add a cache?
Okay, let's talk about it. Why not cache? Where would you add a cache? Now, let's say I draw our regular users like you and me reading that commentary. So what we would be interacting with is we would be interacting with a bunch of API servers. And these API servers up until now were directly talking to database. Now this API server will have connections with masters and replicas. Depending on what the request is, it would make requests either to master or to replica, or rather in this case, it would load balance between all of these three, right? Given that writes are negligible, that's not a problem. The master will accept writes as well as reads and can easily handle it, right? Okay, now you're talking about adding a cache. Why would you want to do that?
So because our concentration is only on the recent match most of the times, we are not going to pull up old data, right? Yeah. So for that, if we cache it, some new user comes up, he wouldn't mind not seeing the latest ball updates. I mean, if we just send out cache results at first.
That's a very wrong assumption. User would always want to see what happened just now. You cannot serve stale data in a cricket match live commentary. Imagine the current ball is 12th over, first ball is bowled, and you're showing him 10th over. They say, "Arey, TV paid 12th over, why you're showing me 10th over?" That's a very poor user experience.
Okay, then maybe something like the write through. The person who is adding the commentary would set like the write request would first go to cache, and then it would be synced to database, and we are serving results from cache directly.
That's a good point. So what you're suggesting is, but then if you add a cache, okay, so what are you storing in cache? Let's start with that. What are you storing in cache? Let's say I add a Redis over here. What are you storing?
The comments, the text, recent text for
What's
for
the
that.
key? What's
Match
the key?
ID, match ID, and then the text comments.
How many?
For a match, I mean, for a match, we can see it for one
Entire match?
I mean, top something for ongoing recent matches.
Recent something. Recent 10, recent 15.
Yeah.
But and like why are we making that choice? If you look carefully, when I showed you that website,
yeah, right.
We scroll down, then we hit that button, load more commentary.
Yes.
Everything about that might be coming from cache. Correct? The recent ones might be coming from the cache. So for each thing, we'll have entire thing, what is stored in our actual database itself, the JSON, entire JSON. And for last, let's say 15 balls, we are storing over here.
Yeah, but then I don't think this is a very large data. Then why didn't they store just all data for that match? I mean, we just saw that for these many matches, we are just taking some 12 GBs. Then why not store all comments for that match in Redis so that you don't have to click on that button?
Great question. Why not all commentaries in Redis? Okay. Anyone wants to take this up? Why we cannot do that? That's our answer. Anubhav and Rahul, in case you want to pitch in, just lower your hands and raise back up. But anyone else wants to take a jab that given that the data is not huge, even I agree data is not huge, why should we not keep everything in Redis and like have database for persistent, but why not serve everything on Redis? Yeah, Siddesh?
I think it's not required. If user is coming, like it's a cost versus like your business thing.
Data is not huge, right? Your entire data is fitting in like some GBs. This is nothing for the in terms like your entire data is easily fittable in one node, and very
No,
easily. It's just 12 GB. And I'm not talking about all the matches. You just recent match one data. It's not huge.
You are only talking about recent match.
Yeah.
Why
The
do
match
you-
which is live. The match which is live at the moment. How many matches would be live at the moment? 10 matches per match, 300 ball. 300 into 10 is 3000. 3000 into 1 KB is 3 MB. Total data is 3 MB.
Yeah, see, I think, okay, maybe
uh,
the things that you store in the cache, everybody has to pay the hit performance. So basically, if you are designing a real-time system, here we don't want to keep caches. See, there is a difference between a 200 gig cache versus a 2 gig cache. The performance will be different. And given the business use case, as far as I see, we want to at least make sure that we are ahead in time with respect to the live telecast, because that is where our business lies. We don't want to spend seconds just to get to the commentary and feed everything in. What I would like is just feed the first 10 to 15 balls, because
most
that is
recent
where,
10 to 15 balls.
That is where everybody is interested in. Rest, they can scroll and come to me. It's fine.
But
That's
why?
what my...
Still, why? Why can I not store everything in cache?
Maybe I don't have that.
Now let's see. This is a really good point, because data is not huge. What's stopping us from doing it? Like why we should not do this? And see, this is what the entire details about, like why are we, like we have this option, why are we not going with it? It needs to be a rational decision. You cannot just say like, and obviously your point is valid that hey, let's serve only the recent part and not other. But Shreya's point is also valid. Why basically why not everything? Let's go a bit more detail. And again, like fab question, Shreya. Thanks for that. Maja aata hai aise isme. Go on. Rahul, your take on this.
So basically, what I think is basically whenever Redis goes down, okay, even though Redis can have persistence and all of those things, but it is kind of like eventually persistent data. So let's just
AOF
say
AOF is immediate persistence. So
okay,
that's not a concern. And
then
in any case, you can load it from database. Loading 300 rows from MySQL DB is nothing for MySQL. You can anyway read it, right?
Yeah.
The data we are playing with is not huge. So it's fine.
Yeah, like I was about thinking about like why not only Redis, like why are we adding like this DB thing? So that's why I thought about like I thought like AOF is eventually persistent. Eventually persistent. It's not like like you just like all the guarantees that database.
Redis first writes to AOF file and then updates the in-memory structure. So yeah. And what you're talking about is RDB, which is basically periodic dump of entire database on disk. That is RDB. AOF gives you immediate persistence.
Okay. Then I guess I don't have any point.
Fine. Chal, I'll pull in Prashant. Go on.
Yeah, so why we should not store it is why to send all the data for every request, right? One ball gets updated, and why to send entire data for just one ball update.
Correct. That's one. Like when someone refreshes the page, and if it's like here we take example of Redis, but what if it's a simple key value in memory database or in memory cache, whose job is that whenever you read, it reads the entire value out of it. Redis still gives you ability to read within the list, but it would still need to store that much big of a list and then do a in-memory read of those pages and get that data and then send it to you. And instead of that, now here, by keeping things simple, we can just plug out Redis and assume it's a very simple use case of whenever I'm reading the latest commentary of a particular match, when my page first loads, I would just have to go to the cache, read whatever value is there against that batch, and I can store it as it, and I can render it as is. If I have, let's say if I'm storing, let's say up until now 200 balls are bold, and if my key value in-memory key value database gives me an ability just to read the entire value every time, now my operations become costly. That now for me to add something into Redis, I have to load that entire list, add something, and then write it back. Right? Redis gives us micro operations, and I'm totally aware of that. But I'm just thinking of, hey, if not Redis, if someone is using, let's say, Memcache, and say it does not support that operation, I'm not sure if it does or does not. But let's say if I want to use any database that does not give me that operation, which gives me that ability to read partial reads from the list, or update the list on the fly without having to read entire list and writing it back, it does not make sense, right? Because that becomes a little heavy operation. But there are some special databases like Redis gives you ability to do that. So you may think of doing it, but why? Why would you want, if you would want to make things as simple when you are reading and writing, just go with the simplest approach possible so that you have very minimal network IO that you are doing. Just to reiterate on this part and conclude this, that in case, assume that your database gives you only value-based operations, which means I could either read entire value and store entire value, and does not give you any granular operations on it. So here we are doing it in a list. What if your value has to be any object, and your database just gives you, given a key, give me the entire value, or given a key, write this entire value. So in that case, the amount of network IO that you would be doing back and forth to do that, or to update or to read, would be huge. So in most cases, because people are more likely to read on the recent things that have happened, it makes sense for us to just store the recent thing. And then what are the chances people would go beyond 15 balls? That's why you see that ClickBuzz also taking an explicit input from us, requiring us to click on that load more commentary, and then it started scrolling. So there you could see that the historical scrolls, like older than 15 balls, are coming actually from pagination API, typically like this. It's going to a database and not to your cache, while the most recent one are going to cache. Right? So it's more about that. And when we start implementing the system, we realize that where we would want to read entire thing, does this database support a partial reading of list from the database or not? Right? A lot of factors depend on that. In case your database does not, you would have to be reading entire value, which is very costly, and write entire value, which is again very costly. So you'd want to keep things a little heavy on the network side of things. Okay, and that's why you typically don't do that. Just because you can does not mean you should, but you can still build that system accordingly because the data is not huge. But why? Unnecessarily. And plus one final thing on that, that in case you are sending this entire data to user every time you would be sending this entire thing to your user. Because now, Shreya, your thing would get even more clearer when we discuss the read part of it. That how a user is reading the commentary, like when a commentator updates the commentary. Before we talk about that, how would user get the commentary, the update, the latest update that have happened? Let's spend some time talking about that. I'll pull you in, Shreya, and then I'll go to Jay. Right, Shreya, go on.
Yeah.
How would that reads happen?
Okay, read could be, I'm thinking pull versus pushed here. I mean, the user is not going to refresh it every time, right? So we need something like push-based model. So yeah, like our
So then WebSockets?
No.
WebSockets?
No. Wait.
Then how would user get it?
So right, yes.
WebSockets, huh?
Yeah.
Okay. So now you added a complexity of WebSockets over here. Okay. I know there has to be someone who adds WebSockets.
So sent events, I guess. Yeah. There's something.
Still a persistent connection, right?
Right.
Okay. Is persistent connection really efficient over here? Like, are we utilizing the persistent connections over here? We know maintaining WebSocket is difficult. We know how expensive sockets can get. Why? Because the connection is kept persistent between the user and the server, right? Now, Shreya, how much of data are we transferring over this persistent connection?
like whatever new comment is added, that is what.
Whatever new comment is added or updated, correct? How much of data? Let's quantify that.
1,000 characters maybe.
1,000 characters every time?
Per second or what?
Per second? Per second, 1,000 characters?
30 seconds, yeah.
Per 30 second, 1,000 characters. Or 1 KB every 30 seconds, which means 2 KB a minute. Not much. So, which means that for 2 events that are happening on every, or 1 event every 30 seconds, you are maintaining a persistent connection which is sitting idle for 29 seconds. For us to maintain persistent connection, you need special servers that handle socket IO, send a message, receive message from that sort of infrastructure complexity. And for a persistent connection, you are just using it once every 30 seconds. Not a good design choice. It's very cost inefficient.
So something like YouTube streaming, which we discussed. Okay.
YouTube chat is very real time, right? Your text messages are very real time. You cannot expect delay there. Here, what if you just do a short poll? Short poll every 5 seconds. Because you know that in cricket, a ball is not bowled, like there is significant delay, at least 10 seconds, at least 30 seconds delay between 2 balls bowled. Correct? You can have a poll frequency of 10 seconds. Simple. Why would you want to add complexities of WebSockets?
Yeah, makes
that
sense.
does not make sense, right? Because we saw while we were designing Slack's real-time chat communication, we saw how complex our architecture became. Because as soon as you add WebSockets, and when there are millions of users reading it, ClickBuzz is India's 8th most visited website. India population multiply karlo, you will get the amount of users that are there. Which means now what you would have is your one edge server will not be able to handle all WebSocket connections. So you need multiple edge servers. Then you need a real-time pops up sitting so that you communicate between servers and broadcast message to everyone. Not worth it. Right? Given that the communication is not real-time, it's pseudo real-time. So to keep the cost of the architecture bare minimum, we don't use WebSockets and we use short poll. And if you open inspect element on ClickBuzz, on ESPN Cricinfo, none of them use WebSockets. All of them short poll because of this exact same reason. Because why? Keep things simple, right? Okay. Yeah. So that's why we go with short poll. And now how would the read happen, Shreya? And then I'll move to Anup. Okay, actually someone else raised the hand and dropped it. Okay, whoever, I think it was Jay, but I'll come to you, Jay, in 2 minutes. I remember. Okay, Shreya, how will the read happen now with short poll?
So every 30 seconds or every 5 seconds, we make a read request and that goes to Redis to get the data.
Correct. Will it go to database ever?
No.
Okay.
I mean, if we are using write through cache, then it won't need to go to database.
All recent writes are going where?
Redis.
So what will read from? Redis. Okay.
Yeah.
Good. Right. So our reads are now very simple. We would have periodic reads happening from this to Redis and back and forth like this. Right. Okay. Redis gives you person. If it goes down, you can come back up and there is no loss of data and whatnot. We can very well handle that. Now let's talk about how commentators are updating this thing. Now this is where another interesting thing comes in. Jay, you want to come in? Then just raise the hand. So then I'll move to Anubhav.
Actually, my question was regarding the Redis cache storage on it.
Okay, super. Fine. Now let's talk about how commentators would update. Now how commentators would write, because now commentators needs a way to write the commentary. How would that flow look like? Anyone except Anubhav and Rahul? Because these folks actively participate. Anyone else wants to jump in? No. Okay. Anubhav, go on. How would commentators comment?
So like given that cost efficiency is one of the things I want to achieve. So I'm thinking like commentators, they must be like, I'm imagining what is happening. They must be watching the match either live or somewhere on the television, typing it. And we can just have a simple like a single server setup where they just execute a script when with the text that they write and it writes to the master.
Script? Commentator, you're asking a commentator. Like imagine commentator writing a script. Okay.
The commentator just writes the text. The server executes the script which writes to the master DB.
But think about it. We just saw a comment getting updated. When I opened the ClickPass website, we saw comment getting updated. How would their interface look like? User interface.
It will be very similar to, I think, to edit form, like a form where you can add and submit and then edit things.
It should have been better, but let me just write. Let's say for every ball, they would have a text box, and then they would have a save button against that.
Yes,
right?
Not submit. Yeah, save
Right?
button.
Save button. So whenever they save, that particular thing gets updated. Right? So if they hit the save button over here, the first ball commentary gets updated with whatever is written over here. Right?
Yeah.
Okay. Now, what happens when this request from front end comes to backend? Where does that writing happens? Like where does it write?
To the master DB.
Okay. So a request came over here. It wrote to master DB. Okay. And then it gets distributed to replica. Replica is now caught up. Then Redis, when is that getting updated?
Okay, if we are doing that, then yeah, first it will.
We have to do Redis anyway. Millions of users reading it, right?
Okay, yeah, my bad. So if since Redis is also there, like first I think we'll have to write to Redis the commentary, and then that will have to be picked up. Yeah, just give me 5 seconds.
Think your time. Think. And FYI for everyone, the class will extend by 10 or 15 minutes. I think I should change the course timing from 9 to 12, not 11:30. I love this kind of discussion. Is right. Go on, Anupam. Take your time. Think about it.
So yeah, now that for each commentary, like since it's being served from Redis, I think our first priority is to write it to the Redis so that any new users that come, they get the latest ball. And then the priority is to write to the master. So yeah, I will first write to Redis and then write to the master. Now, I don't think we should use transactional outbox here because like that is too complex for this simple system. We can just write it in order. Like first write to Redis and then to master.
What if write to Redis succeeds and then write to master fails?
But that is like asking a question, what if our write to master failed like that? I think that will have very similar probability. That could happen even in a simple master system where we write to master and that fails. So
no, but now your commentary is updated over here, but not updated over here. Now what would happen?
From a user experience perspective, I think for them, like they still get the latest commentary. But from our system consistency perspective, like let's say when someone comes back, like after many days of pass, and then they try to read old commentary of the data, this ball's commentary might be missing.
So then that's wrong, na? They would say, "Arey, where is ball number 5? It's gone." Right? That's wrong. You have to ensure data is over here as well.
Yeah. So in that case, like I think we may want to use transactional outbox if that is the requirement.
Okay. I love how people jump to complex solutions. Okay, good. Like I love people making these mistakes because again, as I said, think realistically. Think very realistically. What would happen? Okay, let me put in Rahul. Rahul, what would you do? What are our transactions?
So basically what I'm thinking about was basically to not have Redis actually.
No, let's have it. Let's not confuse everyone. We have Redis. Now what?
So basically like I will take some time. I will go later.
That's it. Gaurav, go on.
So Arpit, for the user who is already active, he will be able to see the last ball. It's the 5th ball, then 6th, and then the next over. So he can be directly served via Redis. Assuming that we have something which either replicates or the Redis and the database that we have, they are kept.
Okay, you are want to keep these two in sync with replication.
Somehow, I'm not I have not connected the PCs yet. It says somehow we do. So only for the new users, we need to, or let's say I log in.
No, but new users are also going to Redis, right? All the reads are happening through Redis only. That's not a problem.
So yeah, every time Redis evicts an entry, because we were storing only the last, let's 15 balls. So the 16th ball goes to memory, and it happens asynchronously.
How? You say 60, so automatically how it would come to
CDC, something like CDC or any complex architecture.
We heard CDC, we heard transaction outbox. Okay. What else? We heard distributed transaction. Okay. What other fancy term you folks want to bring in? I'll suggest my solution, and that's precisely how these companies do that. And I'm not even exaggerating. I have people, like I got some internal news from there, and solution is more simple than you think it is. We love to complicate things, and which is why I love covering this statement, because it makes us think in a very simplistic way, right? You don't need to build complex systems. Simple systems are good enough. Hemant, go on. How would you solve this problem?
I think the problem lies in the commentator who is writing if the submit fails for database. What we are discussing that part.
Yes.
I think immediately whatever the users are seeing is from Redis. We are talking about when somebody later tries to read it, and at that time we need to read from database. So we have enough time when we can sync up this thing. So this can be so let's say I send the details to write, but it may fail. What we can have at the commentator, we can have a write ahead log or a file where we can save it and batch processes. If
basically browser.
Simple.
Browser may you can save this, right?
Yes.
Okay. Index storage in browser, you're saving this environment. Okay.
You can simply save it and retry it if it fails.
Who would retry it? Will commentator retry it, or you will auto retry?
Yeah. So there comes two things. Okay. One is how we will try to have this system checked first. So this looks like a reconciliation problem, that okay, out of 10 things which I have pushed it from commentator, 8 are gone. Let's say 2 are still remaining. It looks like we have like a ordered entries inside this 1, 2, 3, 4, whatever the balls we have written. Okay. What it looks like a reconciliation needed, where at the end of, let's say, each over or something, you send a batch. Okay.
God, you're making things so complicated, Evan. No, wait. Let me cover it. Let me cover it. Sorry for that, but it's too complicated. Ordering, you don't need all of that, because who is this commentator? Our employee. It's not an end user. It's not someone who you cannot control. This guy is sitting in your commentary room and writing this commentary. What a simple solution to this problem is, first of all, this is not a write heavy system. 1 write per minute, any database in the world can handle. And database node going down, very rare thing to happen. And even if it happens, you can cache or you can store this information in your local browser. Right? Okay. Once your database, when this commentator hits this particular save button to update this commentary and hit this save button, what would happen? When this save button is hit, the API call is made over here, which updates your Redis and your database one after another. If any one of them fails, you show this user save unsuccessful. That's it. Please retry. He's your employee. Hit the save button again. It would work, right? Up until the time your database is down, it won't work. But at least it is, you can write a message saying it is saved successful in browser, not in DB. So you can just show a red mark over here that, hey, you may need to resave this again. Don't do auto retry. Don't make things complicated for your end user. Who is your end user over here? It's your employee. It's an internal tool. Right? So just a minute. Let me complete it. Right? Let me complete it. Then more than happy to address this. Right? So keep it really simple. But now what these people would see on their console, for each of the ball, they have the entire commentaries there. they update it and they save it, they see an error in case write to both of them fails. Because whatever, like if one of the database is down, then your write is failing. You can show this message to your end user, which is in this case is your employee, your commentator. And what our commentator would do, it would retry. If it fails, it would save after some time. But in any case, given that it's not a write heavy load, the chances of database, see, a database typically goes down when either there is an infrastructure problem or when there is a very high write load. Read load database typically does not go down. In that case, you have your Redis and your replicas to serve it. Right? So there is very low chance of your master database going down while handling this particular situation. It can go down only because of infrastructure. That is anyway not under control. If you are using any cloud provider, AWS, GCP, Azure, they have standby nodes and whatnot handy. It takes them 5 seconds to replace your database, right? And do a failover of that. Right? So for 5 seconds, they would see this thing and they would be trying to save it again and again and again and again. And once the database comes back up, when they save it, it would save to Redis and to database. That corresponding ball entry which are there, it would be updated for that. And while your end users are continuously reading from here, they're anyway reading from Redis. So whatever the last 15 balls are here, they would be constantly getting served to your users. It's a short poll, right? So you don't need to overcomplicate the situations at all. There is no need, and it's not against any of these policies. These policies are good when it is very high write throughput and something not under your control. Here the thing is, this commentator is your employee. It's your internal portal. You can design it the way it is simple, because you can ask him to do something. You can give them a guide. Hey, if this happens, click this button. If this happens, click this button. You don't have to solve all problems automatically. That's the thing, because here anywhere human is involved in order to comment on a particular point. Right? That's why. Just keep things simple and do this. And by the way, this is precisely how one of the India's top, not CricBuzz, one of the India's top cricket commenting website actually has built their system. This is precisely that architecture. Bunch of read replicas, bunch of Redis, API servers, and an admin and a commentator console that looks and works exactly like that. And it's 16th in the India's most visited website. It's that simple. And they also use short code. They just have a couple of optimizations, which I cannot talk about. But this is precisely what their almost 90% of the architecture looks like. Nothing fancy. Really simple. Right? Okay. Any questions on this?
Yeah.
Go on, Rahul. Sorry. Go on, Hemant, and then I'll put you in down. Go on, Hemant.
Yeah. So initially when we discussed, we said like there are two writes. One is on a Redis, one is on database. Okay. What we were discussing that the write to the database fails.
Correct.
Okay. If I have a console, I thought initially whatever you have proposed as a solution that we can have some marker which says that this save or submit is failed, and then you retry it. What now here the challenge is you as a commentator box console, you have to worry about which write is failed. Is it the Redis failed or it is the database failed?
You don't have to worry about it. When you save, it gets updated in both the cases.
Yeah. So when we saved it, let's say the Redis write is gone correctly, but database write failed. Then only we are saying this save will show unsuccessful. Otherwise, it will say successful. Correct?
Any write failed, we show it unsuccessful. Simple. Any write.
Okay, so we are saying any one of these.
Yeah, any one of them failed, we say it's unsuccessful. Simple.
And then commentator immediately tries again.
Correct. Save again. Because here you would have one entry for each ball. Let's say this is ball number 1.6, sorry, 1.5, 1.4, 1.3, 1.1. When the commentator saves, that corresponding ball entry gets updated over here.
Okay, so maybe then I bit understood.
It's idempotent, right? No matter how many times you save, the corresponding entries would be updated. In this case, a row. In Redis cache, that corresponding entry in the list every time.
Got it. So what I understood is maybe that the write to database is failing. That's why it says you have ordered entries. Maybe you could take 4 or 5 or 1 over entries. If it's one of them or 2 of them are failed,
no.
You send
any
it
one of them, any write failed, you say it's failed. They would retry. It's your employee.
Okay,
right?
Got it. Maybe a bit different. I understood. Okay.
Rahul.
So my question was basically like we are using Redis, and I was thinking, what are we actually? How much data are we storing in it? Basically, like our actual total data is 12 GB, and we are only saving like 10 KBs is in Redis. Okay, so I was actually questioning like, do we really need it? Like we can basically have like in our program, in our like web server, we can have some sort of a cache, like let's just say map of string and string basically, and store that there. Okay, so whenever like there is like whenever the web server starts, it basically gets the data from the DBs for 10 entries or 30 entries, whatever it is, and store it in the memory, in its memory. And also for the commentator, what we can do is we can have something like RabbitMQ or something like that, which pushes the updates to this web servers
That's
cache.
the complex part. All the servers needs to be updated. Why? It's better to go to a central place and read it. Now imagine having to send updates to all the web servers. And if update to one of them fails, that any request coming to that sees stale data. Never have data redundancy and reading from all the places, right? Keep it at a central location. You're simplifying the system. Got it? Because when there are thousands of, when there are 100,000, 200,000 users concurrently reading it, you would have thousands of servers serving those requests. Now it's your responsibility to update cache or like update it in-memory table you're talking about at all the API servers. Why? That's much more complex than just updating at one place, because this is not costly at all.
Like we are running a specific instance and all of those things, like which is storing like 10 KBs of data. So
what's the problem? You're doing it for reads and not for data. It's not about that, hey, I'm storing the small amount of data, that's why I'm doing it. You're simplifying the system. Imagine having a RabbitMQ and then updating all these servers. That's much more complex. What if, because now when it is updating all the servers, what if it updated 500 and left other 500? Who will take care of consistency between them? Huge problem.
Like whenever we consume any message from RabbitMQ, we have to like specify like we have got the data and you.
But that's more complex. Staleness is more in that case, right? Because it's very much possible that 500 servers did not get your update. Other 500 servers did get your update. First 500, any request going to first 500 servers are getting stale data. Problem, right?
Yeah, in that case, they can just retry.
But problem, now you are complicating your solution. Keep things simple. Is there anything simpler than this architecture?
Like it has more components. That's why like I thought like,
RabbitMQ with consistency across API servers versus one Redis. What are you talking, man? One Redis versus one RabbitMQ and consistency issues. Pick one.
Okay, so even in this, it can work also like 10 KB is
right?
premium.
It's not saying, I'm not saying my solution is best one out there. I'm saying it's very simple. You can build your way. I'm not denying it. But how will you ensure that all of your API servers are consistent? You cannot.
Yeah.
That's the problem.
Got it.
Right?
Got
That's
it.
what I'm just simplifying the solution. Nothing against your approach. You can build it the way you like. But the thing is that has these challenges. If you're able to solve it, good enough. If not, then you have to go with the solution. Right?
Sure. Got it.
Okay. Sure. Amrita?
Arpit, my question is that if we're relying too much on the commentator and consider the situation where we have some network delays or something and the same entry gets updated again, or maybe the entry is missed, can't we use a message queue?
Why message queue? Tell me one reason why.
Like to avoid the redundant entries.
There is no redundant entries. It's one entry for each ball over here, one entry for each ball over here. There is no redundant entry.
Like there could be some network delay and maybe the commentator inputted the value twice or something. So to avoid those
Why
kind
would
of
that be a
human
problem?
errors.
No, there would not be any problem, because on console, on their UI, they would see for each ball one text box. They would have update over here. It's always updating for a particular ball. That corresponding row gets updated over here. That's corresponding updates over here. So even if there is no problem, in what's faster than a synchronous write that you are doing? Right?
Right.
Got it?
Yes.
Okay. Just again, I'm putting that entire thing into building simple systems. And here, the things that we did in order to save cost was around not going with complexities of web. We don't want to automatically push. It's easy to do short polling because we are leveraging infrastructure really well over here. WebSocket, maintaining edge servers and real-time PubSub and whatnot, don't need to fall into those traps. You don't need it. Simple HTTP request response works just fine. Doing Redis, serving recent data from here, having a simple commentator console, having a simple database to accept writes and persist it, have synchronous writes and do a retry because commentator is your employee. That's it. Do not overcomplicate your solution. And I'm just stressing that point so that it's easy to use these fancy terms and build systems. It's hard to build systems like this. In most cases, you might think, hey, we just need this pattern, but then your engineering mind kicks in and it starts to overcomplicate things. This system I typically cover to bring you down to that same point that, hey, in real world, whatever works, whatever floats your boat, whatever keeps your product up and running, business up and running, do that. Nothing more, nothing else. Right? Okay. So I'll take questions on this part in some time, Anubhav, Rajiv, and Jay in some time. But let me just quickly cover this part around relevance techniques, right? I'll just take 10-15 minutes to cover this relevance techniques and why it is important. Now, this is the third thing that we were going to discuss today. It's already 11:30, that's why I'm just going over here and then we'll take questions. No problem with that. Okay. So when we design a text-based search engine, the thing that we do, that we'll go a little deeper into search engine, right? How do you maintain that? How do you attain high relevance for search engines? We'll talk about those techniques, right? Okay, so here we can assume that you are using any search engine like Elasticsearch, Solar, Lucene, pick your favorite. All these techniques that we discover will go on top of that, right? Not within that, it will go on top of that. So if you're building a search engine, if you're working in search team of any organization, whatever techniques we discuss, you can apply right away, right? Okay, so what you do is, with respect to relevance technique, most search engines in today's day and age are text-based search engines. You search on Swiggy, Zomato, you search on Google, you search on anywhere. It's always text-based, right? So what matters over here is how are you getting those relevant results from the backend, right? From the search engine, right? So for you to typically have that, you would have your users interacting with your API server, with your search service relying on Elasticsearch to get the data. Now your job in your API server, your business logic is typically creating that Elasticsearch query that gets fired onto Elasticsearch cluster, gives you the relevant documents, and you send it back to the user, right? But there are a few things that you need to worry about. First of all, that what Hemant was constantly pointing around spelling mistakes. We'll start with all of them, go step by step on how different things you can do to make your things relevant. And I've implemented all of them in production. So I did it for a year and a half, day in and day out. And I just love information retrieval as my domain. I just love it because it's so fascinating when you have to play with so much of textual data. So I took all the courses during my master's, all the optional courses that I took were all around information retrieval. I was just in love with this field. But now I'm in love with something else. But yeah, I used to dive deep very much into this. So we'll start with simple one and then we'll go to more complex at every step so that everyone's on the same page. We'll start with a very simple one. So whenever we are putting any document in Elasticsearch, it's typically a JSON document. For example, you are indexing blogs on your platform. Blog will have title, description, tags, keywords, author, and whatnot, right? These basic information you would have in the blog. This JSON document has all of these as attributes, and the value is the actual title, the actual description, and whatnot. This is what you are storing it in Elasticsearch. So when you are searching for something, you typically don't say to Elasticsearch, hey, give me all the document that contains this. You would say, because if there is a document, let's say you are searching for Sachin Tendulkar, the document containing Sachin Tendulkar in title is more relevant than document containing Sachin Tendulkar in description, because it's there in the title. That's the title of the document. If you're searching for a food, let's say burger, the dish having burger in the name is more relevant than the dish having burger in the description. If you're searching for a restaurant, right? So you can apply that out all the places. If you're searching for a course having Python in the title is more relevant Then some statistics course that just uses Python as its programming language. Let's say you want to say Python course. A course having Python in the title, which is Python course, is more relevant than any course that is just using Python as a programming language to explain something, right? So you would typically give different weights to different fields and then use them to rank. So that is one of the ways you make results more relevant. It's a very common way to do so, right? That's a simple one that almost everyone starts with. Now the next part is around fuzzy searching. This is where, always remember, people make we all make typos, right? But Google automatically understands it. So the second relevance technique is about fuzzy searching. So what fuzzy searching does is fuzzy searching, whatever input you gave in the search query, it would not try to spell correct it. Spell correction is different. That's the third point. Spell correction is different. Fuzzy searching is different. So fuzzy searching searches your search engine fuzzily, which means that, let's say, if you type in for 3 characters, it takes 1 character of fuzziness allowed, which is basically edit distance, right? So when you do a fuzzy search on your database, what happens is whatever thing you are searching, it would match every word which is 1 edit distance away from it. So if you search for LAT, it would match all the documents. It would consider all the words that are 1 edit distance away from this, which means lat itself as is, then any word which is 1 edit distance away, bat, cat, hat, bat, fat, mad, hat, whatever you would want to put it. Any word that is 1 edit distance away from this is also matched, right? So this increases your chances to handle typos, but in a correctly typed thing, it would reduce the relevance, because now when you search for bat, bat would also mean cat and lat and dat and bat and hat and whatnot, because for the system, it is you are allowing a tolerance level of 1 character typo for 3 character word. It would not matter. It would still give preference to one having 0 edit distance match, then 1 edit distance match, but you're still matching those other candidates. Always remember this. So fuzzy searching is not doing spell correction. It is doing fuzzy searching, because a lot of people get confused between these two. That's why I'm clearing it in this depth. That fuzzy searching simply takes the word and searches it fuzzily, which means that it would allow 1 edit distance difference between any word that matches. So even if you search for bat, it would match bat, cat, hat, mat, everything. And then it would then use whatever ranking scheme you gave it, but it's just improving your candidate matches that you have. And now with this, what happens is, but it would still give preference to the one that is 0 edit distance away, which means bat in document that contains bat is more relevant than you search for bat and document contains cat. But it would still match the document that contains cat. That's important. This is fuzzy searching. And the way search engine implements them is using a data structure called BK trees, just a Google search away to figure out. It just basically stores the data in a way that it is storing data which is edit distance based. So the distance between 2 nodes is equal to edit distance. So the way they are linking is edit distance based. So go through BK trees in case you are interested into knowing the internals. Right? This is fuzzy searching, which just fuzzily searches everything. The next one is spell correction. Spell correction is what you do when you would want to know, hey, user typed this seems wrong. Let me find out what the correct spelling is. And then let me search that correct thing in my database. Right? So here it is very domain specific. So every product would have its own dictionary of word. For example, for a product which is like Swiggy, the dictionary would be food items. Paneer biryani, veg biryani, this, that, naan, roti, sabji, dal, chawal, whatnot. Right? That would be the dictionary for that. If user misspells something, and what first thing it would do? Whenever the query comes in, it first checks in the dictionary that, hey, are the words in the query, are all of them in my dictionary? If yes, good enough. We pass it to search. If not, for the words that are not there in the dictionary, can we find a closest word? This is spell correction. You are correcting the spelling. You are not fuzzily searching. You are correcting the spelling and then searching the correcting. So let's say while typing, you type HOUPE instead of House. And let's say house is in your dictionary or is in your vocabulary. What you do is you convert HOUPE into HOUSE and then search HOUSE internally. This is what Google does when you misspell something. It says, did you mean this? It does spell correction for you. The spelling that you typed is wrong. This is the correct spelling. Did you mean this? This is spell correction. So spell correction is very domain specific on what you are building, what you are powering, and it would convert the misspelled words into correctly spelled words and then search it. This is the difference between fuzzy searching and spell correction. The next one is synonymic expansion. So what synonymic expansion does is, let's say you have the word house, a lot of document which contains, for example, I'll give an example. Harry Potter. Harry Potter has 4 houses: Gryffindor, Ravenclaw, Slytherin, Hufflepuff. So always people forget Hufflepuff and Hufflepuff. So now what happens is, let's say someone writes in Gryffindor home. You have a document that contains Gryffindor house, but not Gryffindor home. But house and home are synonym. So if someone searches for Gryffindor home, it should also match Gryffindor house. This is what synonymic expansion is all about. That home is equal to house. So if people search for home, also match the documents that contains house and then rank them. Right? So it's all about matching a lot of documents over here. So you have synonyms like this. For example, home, house, USA, America. USA is equal to America. So if someone searches for America, you also match the document that contains USA. If someone searches for USA, you also match the document that contains the word America. This is synonymic expansion. For example, let's say someone search for Sachin Tendulkar, but Sachin Tendulkar is also called as Master Blaster, right? So if someone searches for Master Blaster, you should match the document that contains Sachin Tendulkar. Correct? These things. This is synonymic expansion. So what you have is, for your search engine, for your domain, you create synonymic expansion list. That this is the word and these are the synonyms. Another, like these are the group of synonyms and this is how you match it. So for example, for an application like Swiggy or Zomato, let me give an example. 2 dishes. Okay. Basically, bhindi fry is same as lady finger fry is same as okra fry. Right? Or same thing goes with Big Basket or your basically online grocery shop. Bhindi is equal to okra is equal to lady finger. People can search for anything. They can search for bhindi, they can search for okra, they can search for lady finger. And given that they can search for anything, these are synonyms. They all mean the exact same thing. Right? And this is a great way to build multilingual search engines, which accepts input typed in English in any languages. So people go to Big Basket and type dhania. They mean coriander leaves, but they type in dhania. But dhania is equal to coriander leaves. So what Big Basket would be having is, they would be having the synonym list. And then first they would do synonymic expansion and then write Elasticsearch query and then fire on Elasticsearch. So synonymic expansion does wonders when it comes to increasing relevance. Okay. The next one, and my personal favorite, is phonetic search. Phonetic search is what makes, like, humans typically don't know the spelling, but they know the sound of the word. For example, I'll give a word. This is not me exaggerating, but literally I wanted to write Arnold Schwarzenegger. I could not write the same spelling thrice and I don't even know what the correct spelling of his surname is, but I know how it sounds. So Arnold Schwarzenegger, I don't know. This is 3 times me actually, and I'm not even exaggerating that I deliberately made those mistakes. This is me writing his name 3 times. Every time I wrote a new spelling. But if you look carefully, all these 3 sound very similar. So what happens is, in most cases, people don't know the spelling of the word. They might not even know how close it gets, but they would sound very similar to each other. For example, let me take simple example for that. Video. A lot of people write video spelling as VEDIO. Tier 2, Tier 3 people, if you're building any platform for those people, a lot of people, and not even Tier 2, even students type VEDIO as spelling of video, not VIDEO. Because video, this seems so natural to write video, VEDIO. to be really honest, after spending 1 year in search, even I was thinking video spelling is VEDIO because I read it so many times. So VEDIO is same as VIDEO, but you can either choose to handle it with synonym, but a better way to handle this is with phonetics. What phonetics does is phonetics converts every word to a root sound. For example, the root sound word for video is VDO. So VIDEO also changes to VDO, VIDE or VEDIO also changes to VDO. There are algorithms to do that. Metaphone is what I personally used. Soundex is a good one. I use Metaphone to build this. So what we do is when we index data in Elasticsearch, we take all the data, we extract keywords out of it. Those keywords are converted to Metaphone's root word, and we also store these root words internally. Right? So for each document, we have the raw form, we have processed form, we have phonetics, and everything in that one huge document on which we then match. Now, what this helps us? This helps us in solving problems like this, where it's hard to know people names, especially when you're building a service that serves users across all the world. You might not know the spelling of that surname of that particular person belonging to other nationality. It's not being racist. It's about you not knowing the spelling of their name, but you know how it sounds. When you want to match that, this comes in very handy. For example, when someone doesn't know English really well, but they know how the word sounds, they would type a word that is similar sounding with incorrect spelling. Phonetics helps you solve these problems really well. Right? And the final one is query segmentation, because people forget to type space. How many times have you searched on Google and you forget space, but you still hit the search button? It's Google's problem. Let them figure out how to do it. And Google brilliantly identifies where to put that space. This is called query segmentation, where given the word, it knows where to correctly put the space and then search it. So the first step, when you pass in any search query to a search engine, a good search engine, the first step we do is we understand, is there a need of a space somewhere? If yes, let me put it there. And then we take that space and then we do other part queries, and then we do other part phonetics, synonymic expansion, fuzzy searching and whatnot. We compile an Elasticsearch query and then fire on the Elasticsearch, get the result and send it back to the business. Right? Google has ruined all of us. Even I agree to that we misspell things and we do this, but yeah, given that people are used to that now, almost all good companies, the search engine, people expect their search to work the way Google works. So all of this is mandatory for almost all the companies to do. Right? And these are relevant techniques that almost everyone working in search team, or where it's user facing search, a simple search box, they all have to do something on this. May not be all, in some cases all, like I have to build all of them because my target audience was tier 2, tier 3 audience mostly. They were very bad with English spelling, but all of our data was in English. So I had to build almost all of this on top of Elasticsearch. So Elasticsearch gives us a lot of, Elasticsearch gives us other features that typically don't give us something which is domain specific. Anything which is domain specific, which is like query segmentation, phonetic and synonyms, we have to take care of, and also spell correction. But fuzzy searching and weighted search, this is what Elasticsearch gives you out of the box. But for us to take the search to the next level, all of this we have to do. Right? And in case the domain of search engines interest you a bit, read this book called Introduction to IR by Christopher Manning, one of the best introductory books on information retrieval. This was my textbook when I took information retrieval as a course during my master's. I loved this book and I love that course. Right? But it showed that how we take search engines for granted. And this makes, like, when you start implementing, you would have, and again, highly recommend you to implement all of this rather than just reading it, but at least read it. And then if you have time, try to implement all of this. It's not really difficult to implement all of this. There are tons of blogs, tons of materials around it, tons of GitHub projects around it, but start to experiment with these things to get a deeper understanding. Right? And yeah, this is all what I wanted to cover as part of building relevance in search engines. What you would typically do in organization rather than going into the math part of it. But this is what you would definitely need if you're working in any search team for any consumer facing product. Right? Okay. Any questions around relevance? Then we go step by step forward. No, sorry, backward. Any questions on relevance? Yeah, go on, Anubhav.
Here, but I had a general question that is related to searching. It's not very specific
Go on.
relevant. So I may be lacking conceptually, but what I'm not able to understand how invalidation happens when, let's say, the entire search set is updated on Elasticsearch. We index that whatever is the search set, we create an index for that, right? Whenever we update that at the source of truth, how does invalidation happen? Do we have to
normal asynchronous job? You know what are documents updated, you would go and reindex those documents. It's a normal reindexing job. It's not invalidation. Cache invalidation implies you deleting those stuff. You never delete from search engine. You update it, right? Just a minute. Hello?
Yeah.
Yeah, okay, got it. So the thing is, you always, when you say invalidation, it's about deleting something. Like cache gets invalidated, implies you're deleting that key from the cache. When you say in search case, you do reindexing. Things that are updated, take those events in Kafka, write a consumer that reindexes the documents in Elasticsearch. Basically updating the document in Elasticsearch.
And very similarly, we'll have to do for like if our domain knowledge changes for query segmentation, synonym.
Yeah. You would have to do reindexing. Wherever you are storing anything in Elasticsearch, you would have to do reindexing of those.
Understood. We cannot do that by a process directly listening to the source of truth and then making that.
No. But in any case, someone has to update it on Elasticsearch. Elasticsearch cannot pull it, right? Elasticsearch is a search engine. Elasticsearch cannot pull the data. You have to index the data there.
Understood. Yeah, thank you. That's it.
Thanks. Yeah. Shreya?
How is that again time phenomena taken care of? Like some searches are very very hit. Let's say COVID was hit during 2019, 2020, but now it won't be. So how is time taken, this time feature taken care of in search? Like how do you?
What you do? Got it. So
Yeah,
that typically happens is like how are you ranking those things? And so that is your ranking part. So when you talk about ranking, that how relevant is this result right now, or how frequently are you getting this? So it's more about what you do is you analyze what is being searched at a moment. You extract domain entity knowledge out of it. I can go into details of it, but that's huge discussion on its own. But to extract the domain entity out of it and tag the documents with the domain entity, rank them. So you basically add a numerical factor, a weight to this document, which is on the basis of recency. That how recent is this document? It may not be time. It may be how popular is this topic in general. So that comes up in your search results. So there is an exponential decay that you put in for a document. That hey, a document, if it is not updated for a long time, decay the importance of that. So you have those additional fields in your search engines. So apart from all the titles and the descriptions and the tags, there are other numerical fields that takes care of how recent is this item, when was it last updated, what's the overall reputation of this document or this entity, and then you have an exponential decay on top of it.
Okay.
This is just a very high level overview of it. Like a lot of math is involved there, but can dive deep into them.
Okay, yeah, thank you.
Okay. But in most cases, if you are like in most cases, your query has to be, it's just not that if a thing is trending, I'll show it in every search result. And that's what would ever happen. You would still be, your results would be relevant to the search query that is provided. And then ranking might take care of what the correct status is. Like, for example, when someone searches for COVID, at that time, the results from official sources were given priority over non-official sources. So someone's blog might not be the first result, but WHO website would always come first. That is a reputation of that website. So for some type of query, you focus on reputation of the website. For some type of query, you focus on something else. Right? So all these factors are actually considered.
Yeah. Okay.
Right? And just to conclude that, how that is considered is by adding numerical fields that quantifies that. For example, for a particular document or for a particular web page, the reputation of the domain, the reputation of that website is quantified in some number. Wikipedia has the highest reputation. That's why you see Wikipedia searches always coming on top. Right? Similarly, WHO would have higher. For example, government websites would have higher ranks. My website would not have higher ranks. So if you search for something, unless you type Arpit in this thing, Arpit in the search query, my website would not come back up. Right? So this is how, so you find out way to quantify it and then use it for your ranking. Candidates might match many, but ranking would solve that for you.
So that's a job which does that exponential decay.
Correct. So that is taken care of other jobs. So that would be continuously putting and updating the data on that Elasticsearch. So it's not just whatever document is updated are getting there, but also this special numerical values that you are using to quantify ranks of the website, reputation of the website, and whatnot. Those continuously update those numerical fields in each of the document which you use for rank. Okay, Rajiv, go on.
Can we go back a bit now from search to design to ClickBuzz?
No. First, let's cover search part.
No, I don't have anything here.
Okay. Any other question? Okay. Any other question? Anyone for this? Search results, search relevance, anything? No? Okay. Let's move to ClickBuzz. Go on, Rajiv.
ClickBuzz, I just got defocused on the read path. I'll just reiterate what I understood there. Read path, he said that we will read from Redis where we want to read first 15 commentaries, right? So is it the bounded buffer?
Yeah,
only
it's a bounded.
First...
That's why only first 15 balls.
Okay,
only most recent 15 balls would be stored here.
The reason why I mentioned bounded buffer is I got defocused. That's why I just heard that the read part would always hit Redis, right? So when you scroll down to see what was the context before 15, then here.
Then it will go to database. Yes.
Oh, I thought it goes to Redis and then there's a bounded. So how it would work? Okay.
No. So the most recent read would always go over here, the first page, right? When the web page is loaded or when the short poll is triggering, it will only read from here. The pagination will always happen from your database.
Right, and then looking like you said, eighth priority wise, eighth rank is the So if let's say all India, Pakistan matches going on, and then you want to you're busy. So Redis part right now, look, we want
Clusters.
to cluster. Then that means also that commentator thing, that script, that servers, web servers.
No, read replicas. No? These are read replicas on Redis. Or Redis also you can configure read replicas.
Okay, understood. Around commentator, like he's a person, right? So I was just thinking from his perspective, like let's say you are in a match context where it's a regular job for you, right, to update comments there. You are in a match situation where you are focused on the match and you're just typing because typing is a job, right? So let's say you are typing, your critical overlay is going on, you're just typing something and then you're hitting save, you're typing, hitting save. And then if you go to the screen and see, okay, one save didn't work, it's just unsuccessful, right? You just go and hit save again. But in the context, what happens at 1.2, let's say 49.2 wall was unsuccessful save, but 49.3 and 40.4 went ahead, right? For some reason.
That would never happen. You would see that, hey, the historical thing, because the first thing is anyway saved, right? Now, if you're saying that ball is not even saved at all, no entries made from that, you would not allow. That's the job of this interface, to not allow writes happening after that.
Okay, so if one is not saved, you won't allow anything to go ahead.
Yeah, I would. But if something is written over there, that ball entry is being made, but updates are not going in that, then I can still continue processing other stuff. That's a part of your interface. You can just block the save buttons.
No, ball entry is not made. I didn't get it, but ball entry is not made. Can you explain
because
again?
Commentaries are updated. We saw in the demo.
Yeah.
Commentaries are updated. One ball is bold. Imagine when a text commentator writes, he would not write an entire commentary in one shot.
Correct.
He would write ball 4. That's it. Let's say Lasith Palika to Virat Kohli 4. And then after some time you see details. Virat Kohli hit a cover drive, ball went there, fielder tried to stop it, fielder fell down, ball went for 4. Commentaries are constantly getting updated. So what is happening over there is that if the entry is there, then you can still allow them to write, then publish other balls because that entry is already made. But if that you cannot, your front end can disallow writing 1.3 unless 1.2 is there.
Achha, okay, update part. Okay, I understood. Update part is allowed, but unless the older entry is not inserted,
Correct.
you can't allow. Okay.
So
now
1.3 cannot go before 1.2. Got it?
Okay, I understood now. Yeah. Thank you.
Sure. Anubhav?
Yeah, so I too had a question about this part only. What I wanted to, like, I was also thinking like Rajiv from the commentator's perspective, what would be happening? I'm assuming that on a single commentator, who's the primary commentator, they will be focused on watching the match and then getting out some early comment as soon as possible. Then it's possible that someone else might be editing
Elaborating it. Perfect. Yeah.
So with that respect, like I think what we might want is to prevent the second support editor to
Yeah, we
maybe
would have multiple editors, right? That's not a problem. You would have multiple editors over here.
using the same browser. Is that how we are?
No, not same browser. Even if browsers are different, then that's not a problem. No?
Then, but we might need to have logic to prevent the support editor from update or writing to this particular ball before the main commentator has written his.
That would not write, right? That second one would refresh the page and get this thing and then update, right? If you are having that sort of thing. Correct? They are your employees. You can ask them those things. Before you do it, because this commentator would shout, hey, I've written, go and elaborate it. Correct? He would tell, he can shout, they're all sitting in the same room. It's a big thing for that company. Correct?
Yeah.
Right? You can put a lot of, because these are your employees. You can put those constraints, hey, before doing this, you cannot do this. Like, and your system can disallow creating those entries if you want to make your backend smart enough. But I'm just saying that, hey, it's a war room where all the commentators are sitting. Why would you want to overcomplicate it at any case? Keep it simple. Okay?
Like just a small follow-up on that is like the reason which I can think of to like make it a bit more complicated is allow the main commentator and all like to shift their mental bandwidth to watching the match and automate these retries and all these part of the system and let the system handle
Not necessarily. Retries would make, because then the problem is your commentator is not a technical person. How will you explain to that person, hey, because of our cache problem, it is here. You think it is saved, but it will save after some time. Humans, they are not technical person. They don't know delays. They don't know replication. For them, save is save. Done. They have to be 100% sure on what is there and what is not. You cannot give them, after some time it will be there. That's not allowed. When you say save, it means if someone refreshes the page or if that commentator refreshes the page, it should be there. These are non-tech people. They don't understand this part, right? So you cannot give them this thing, you just save, it would automatically save or you would retry. Obviously, you can build this part. But in these cases, when you're dealing with non-tech folks, consistency is more important. You give them, if failed, show them it's failed. Let them retry. Let them have that confidence that when they hit the save and it says saved successful, it means saved is successful. Think of it like you doing your taxes and on government website that is not getting updated. They cannot say, it will happen in some time. Because you are not in that domain. For you, it's very stressful work. It's a save, it should be saved. I don't care about anything else, right? That way.
Yeah, understood. That user experience makes more sense.
Right? So you consider your end user and try to keep it, let them have the least headache while using this. So automation is typically a headache for someone who does not know that system well. And you cannot just be like, it will auto retry. Because they don't know. Because their next update is dependent on this thing. Because right now they just wrote one small line. They want to elaborate. And then maybe they did a typo. They want to change that thing. They cannot wait, it will auto retry. I'm not sure if it happened or not. And now how would that happen? Now you have to handle that consistency. Simple. Either save or not save. Right?
Yeah, makes sense. Thank you.
Yeah. And in any case, only 1 or 2 people are writing. Not a write heavy system. You don't need automations everywhere. Simple. That's why. Okay. Okay. Pankaj, go on.
Yeah, Arpit, so I was just thinking of another way of designing here. So since you mentioned, right, that we have the control over, who is writing to our system. can we just give them an option of save to DB also and just keep on saving data to Redis? And when they press that save to DB, like let's say at the end of the match, we just take all of the data from our Redis and put it in the database.
Don't do it automatically. Don't. Why? Because for them, what if this had a major disk crash? Everything crashed. Then before they do it on DP, what if that data is gone? Unfortunately, it happened. Keep it simple. Why? Why is it unnecessary to copy data from Redis and put it into DB? Why?
No, I was just trying to like basically avoiding like updates to DB at regular intervals because anyways we don't need it, right? We just need
But
the
it's
Redis
okay. This is okay, right? This one write onto this database, what worse would happen over here because of that one write? Nothing. One write, 2 writes per minute. Nothing for MySQL, right? 2 writes per minute, not even seconds. 2 writes per minute for one match. Let's say, what if there are 10 matches? So 20 writes per minute. Nothing for this database. And it's just that I'm just trying to reduce that additional moving parts. Right? Why? And asking those, why do you, yeah, you can build it. Should you? Right. Then you need another thing that takes the data and then puts it there. Then you have to do reconciliation over here, see merge conflicts and all, because that might be possible that, hey, this might have some stale data. This might have some latest data due to any reason, problems. Keep it simple. 2 writes at 2 places. Both successful, then you are successful, other unsuccessful, let commentator keep on retrying unless this site comes back up. Simple, right?
Yeah. Okay.
And now, and again, just to do that, again, for everyone, if you look carefully, that we can see a clear distinction where we auto retry and where we don't. If that person, your end user is your employee, you typically want to keep things simple. If it's end users and there are multiple writes happening, you don't want to give bad user experience to that person. So think of user experience when you would want to do auto retries and all, right? Do you really need that? For Instagram, it might make sense because it's end users. Why would Instagram want us to take care of the day? It's not saved, please do it again. In some cases, it might do auto retry. But in this case, it's your employee, you can ask them to auto retry. Right? So keep those things in mind that where you need to complicate your situation, where you want to have those automations in check, and where there might be an overkill for that. Right? Okay, Siddesh.
Hey, Arpit, I have a question on this ClickBus thing. So yeah, let me understand first. So this Redis, the whole deployment is on different machines, right?
Yeah.
Okay. Yeah. So I just wanted to, like, somebody has already raised the point. So I like, given that this is a problem with cost, right, with our solution. So I was going to propose a solution where we can reduce this cost.
Right.
Okay. So basically what I was thinking was the data that we want to keep, imagine like 100 live matches and 100 balls, and 1 kilobyte per ball is 10 megabytes, which any machine API server RAM itself would have it, right? That is where I start. Now, so basically what I'm saying is, let's replicate the Redis replicas we can get rid of by keeping the cache in the API servers itself. The problem is, how do you publish to API servers? Okay, now I'll do some calculation for how many API servers do we need. Now, considering the India's population of 1.5 billion, imagine you have like, I don't know if those are like, I am calculating it right, so correct me
That's
there.
right.
Yeah. So imagine 10% of traffic is coming to your website, which is like 150 million. Now, if you see these HTTP requests, I just Google searched like 10 kilobyte of HTTP request, one single API server with 2 CPUs can handle 400K. Okay. So I did that calculation. It seems 400 machines are fine. So basically we can auto scale, but if we get to the scale of this traffic, we need 400 machines. Now I was thinking, if I replace this Redis cache with a Redis PubSub, which I can do in a single machine with 375 persistent connections anyways. What if my commentator just pushes, like there is a single channel, which is a match channel per channel. Okay. Whenever I push to that, API server gets it. It is in the cache. All of your network IO is avoided. And the API server will be even more faster, I think, because you will directly return it from your own cache.
Okay, got it. The problem with that is Redis PubSub does not give you any persistence, which means that at given point in time, let's say one of the API servers connection is broken, it would not receive the updates that you made there.
Got it. Yes. Yes. Yeah. I know this limitation. And what I was thinking is, anyways, when an API server understands this, right, it can do a read call, because anyways API server,
How?
once it goes.
Acha, okay. It would anyway do it on the safer side, that whenever the connection is broken, it would do a retry.
It would do a retry. Anyways, right. You are going to establish a persistent collections, just read out the whole thing. How much is that? Some few megabytes.
But I still feel that is more complicated than reading. You are now having
really?
this challenge of
No.
I mean, because you would have to keep ensuring that it is consistent across. Now, for example, if two reads back to back went to two different servers, let's say one of the reasons, due to some reason, the network on particular API server is choked up. Due to any reason. Now, for example, let me
Makes sense.
Yeah. Right. So if it is not able to process it and update its in-memory cache or map or list. Now the problem with that is any request going there would have stale data.
No, but Arpit, that's easy to solve, right? We know anyways that what is our latest ball, let's say 10.3 overs or 10.2. Is it that difficult to solve the stale data problem? I mean, we don't even need any more logic than just a client-side handling.
Yeah, you can, and that's what I'm saying. I'm not denying that solution. It's just that I feel that is
I agree.
Then having this, right?
No.
Having to
I wanted to brainstorm with you. There's nothing right or wrong in this.
I always say you can build it. Yeah. You can build it. It is just that for me, solving for consistency across API servers is a bigger problem than putting in $50 cash in cash. Right? I would save that.
That is where I was going to get to. How much cost are we talking about? That is what my next question was. Maybe I'm over. How much cost is this really? Does that make sense?
Let's assume you need how many Redis servers? 10 Redis servers. Worst case, very high read traffic, 10 Redis servers. 10 Redis servers, each Redis server with 1 GB RAM, good enough. Let's say you have 32 GB RAM on each Redis server. If you compute the cost, hardly $120 a month.
I see.
Okay. That you will earn in 1 hour advertisements. Right? So that's the thing is, you can, hyper optimize your system to have literal zero cost. But at some stage, you need to draw that line at, hey, beyond this, I might not want to.
Makes sense.
A lot of guarantees are given to you. You just go for it. And it's not that your solution is wrong. You can very well implement it. Even I can go a step beyond that and try to reduce this or change this to directly S3. I don't want a relational database.
Agreed.
Let me store it on S3. Right? I would say even that cost, but should we? Right? Should we? At one step, you might want to stop and say, this is good enough. Because that's the classic Pareto principle. With 20% of efforts, you can get 80% of chop down in your cost. You stop there. I'm happy with this 20%, because then solving for this rest of 20% optimization, you need a lot of complexity. So drawing that line there.
Agreed. Yeah. That's good.
Yeah. And we anyway discussed that same point before this. I think someone mentioned that same point. But again, as I say, you can build systems however you want. It's just that you need to understand why you're making a certain decision and get an approval from a senior. Good. Okay, fine. So I just
one more question.
Just a minute. I'm just dropping the links for folks before folks drop off. Link to testimonial and link to rating. Please leave your testimonial. It would mean the world to me. A lot of folks have already dropped off, but still, folks who are here, who are listening to this, please, it would mean the world to me. Okay. Fine. Raj, go on, Siddharth. You have one more question.
Yeah, I have one more question. I have a question on the original, the first design that we made.
Okay.
I'm still
Can we wait for
with...
2 minutes? Can we wait for 2 minutes? We'll just wrap this up, then we'll go to that. Right. So that the context is not lost. Raj, go
on. Arpit, now I have one use case where I'll start for the use case first and we'll go back to design later. Let's say you and me are sitting side by side and we're watching some final match, and then you say to me, okay, we won, India won, right? And then I'm on page and it's okay, nahi, no yaar, abhi 2 ball bachi hai, abhi ka jeet gaye. So this is because you are reading through the Redis, because Redis has a latest image of what's happening, and then due to the replication lag, this could happen, right? I'm reading from different Redis.
Replication lag? Okay, no, between Redis there would not be replication lag. Why?
Short poll was there. I was thinking short poll. You are putting Redis basically.
This is read, right? where like you are saying that because we would have multiple Redis server, each server can have different replication lag, right? So this might be at 19.1 over, this might be 19.5 over, correct? Right? So which is what you're talking about, right?
Yes, yes.
Now, my counter is that there will be almost zero replication lag.
Because write throughput is less.
Exactly.
Right.
Exactly.
Okay, I was just trying to wrap my head around that. Okay, if the
See,
right.
why? Let's talk about. Let me like this. I love this one. Let me talk about it. Why replication lag even exists?
When you're trying to replicate some data across machines, you will have to send it to a network, and then based on different machines, due to network, some problems in network, the data packet might land up very late.
No, it's not network. It's not network. A lot of people think it's network. Network, because in most cases in data centers, networks are pretty much standard. They are pretty much sorted, right? The problem is typically not with the network.
Network partitioning?
No.
Okay.
The problem is with the processing that your replica has to do. So how does
CPU bound?
work?
Okay.
Right. So what happens? Your replicas have limited CPU. Read requests are coming to replica. Replica is pulling data from master, right? Now the thing is, if replica is overburdened with a lot of requests coming in, it would not get CPU to read the data from the master.
Right. Yes.
This leads to replication lag, right? Okay. So now, if the amount of writes are small, which means the number of updates that you are making are small, which means that even if your replica gets a small CPU, that thread that is replicating from master gets even a bit of CPU every second, a small chunk of it, it can read the data from the master. It does not have to, because what replica does, it reads the data from master, not the data, rather let me put it that way. It reads the queries which are fired on the master and reruns those queries on the replica, on its data store, right? So if the write throughput is less, there is very less queries that your replicas would read and would apply it on its own data set. So this way, even if your replica is read heavy, is serving a lot of read requests, even if that thread gets small chunk of CPU, even it's just 2 writes per minute, or let's say 20 writes per minute, it's peanuts for it, because it would send it in batch, it would get all of these writes together. For them, applying this write is not very consumed. So it's very quick for your replicas to quote unquote catch up. It's not going to be long enough, right?
Network partitioning is always true, right? It always happens.
How frequently have you seen your network partitioning happening in production for this cluster?
Not very frequently, not very frequently, to be honest. But if you take into equation that thing, let's take it into equation.
If you take about network partitioning, what is network partitioning? That a lot of databases are just chopped from the network.
Right.
But few of them are there.
Yeah.
If you know, when would they come back in network?
What network connection?
Come back in network?
So when they're able to reach out to each other, right? They are able to communicate through a network. And when the network is up, basically, whatever was the cause is resolved, and network is up. So they then try to synchronize whatever was missed between them, right?
Correct.
In that case, if you
God, in that case.
In that case, I mean, same problem. What was same use case which I started with? My replica didn't get updated because of network partitioning. I'm just saying, okay, abhi to 2 ball bachi hai, and you said, okay, nahi jeet gaye. So there is a inconsistency, but availability.
I agree. There will be inconsistency in case of network partitioning. 100% agree. Okay. But now
the question boils down to the network partitioning frequency, basically. Yes.
No, not even that. I'm talking even a step before. How much of data, let's say your network partitioning, how big your network partitioning can last for? 5 minutes? 10 minutes? Worst case, right? In 10 minutes, how many writes are you missing? For each
we said
match,
two writes per minute, right?
2 writes per minute, right? Now, 2 writes per minute for each match. So 20 writes per match is what you would have missed on.
200 writes per 10 matches.
200 writes per 10 minutes. For you to replicate this 200 writes, it is very quick. So when it joins the network or it becomes part of this cluster, for it to read from this would be very fast, because it's not write through. There are not many writes that it needs to catch up on. So there would still be lag, and I'm not denying there would still be a lag in case that it just joined the server, but before it can get this 200 writes, someone made a read. Very small window. right? Very small window we are worrying about. And in that case, it's okay. It's not an end of the world because user might say, "Arey, it's remaining." User would do a refresh because in the next short poll, it would go and buy it, then it would have anyway be there. Right. So
Right.
the window in which it will, and I'm not denying it will get affected. Network partitioning affects a ton of stuff. Right. But in that case, that when it joins back the network before this 200 writes propagate, that time the read that goes in, those are the ones that are affected. And that is a very small window because this 200 writes are peanuts for this database to replicate. So you have a very small window where it would be affected. Very small window. I think it's okay to not optimize for that, given that this is not an end of the world problem statement. If you want to sort that out by any means, then I go for high availability. In that case, write it at multiple. You are anyway writing at multiple. Other nodes are anyway having the data. One node, one write missing here or there. That's okay. And if you're going for very strong, consistent reads, in case, then read from multiple redises. Pick the one that is common across most, and then you serve it. If
Consensus.
you're still actually basic consensus, you basically doing read level consensus. You solve that problem. You over engineer that and solve it. I would go for that one slight inconsistency there because it's very small thing. But again, that's a good problem to have, that you at least know the solution where you need strong read consistency. You read from multiple data nodes, pick the one that occurs the most number of times, and you serve it to the user.
One thing I like about this course was that when you are thrown a problem, instead of jumping to solve the problem, you take a step back and see why even to solve this problem. How can we avoid this problem at all, right? So, I mean, today's discussion, it was a big takeaway that instead of jumping and wasting your CPU cycles to solve the problem, just take a step back. It's very easier to how not to solve the problem, and then life is easier.
Yeah, I just try to put because I've done a lot of things practically and build real systems, which is why I see because that's what my seniors always used to. I repeat, this is not even I used to be like this. I used to use all the fancy terms thinking that I am the smartest one in the room. But when they asked me this critical question, I learned the hard way that most of my solutions that I designed 5 years back was stupid as shit. Because of this, because I used to always over engineer. When I started working at early stage companies, I realized that, hey, asking those critical questions is really important. You don't need almost you need to know how to solve them, but you don't need the best engineered solution every time. You just ask those questions.
The best way to understand is the frequency at you're operating. If you have implemented the solutions, you are different frequency. If you are learning things, then you're different frequency. So change frequency is important to understand these stuff, how to take a step back and see.
But this is one of the most important things I'm learning at Google at the moment. Like, I would highly recommend all of you to think on those lines, that ask those critical questions. Like, my senior staff asked me such tough questions. Man, I'm shit scared when I have a meeting with him. I'm like, I think I designed good solutions. No, he asked me those critical questions that makes me challenge like every single thing, like even a byte format, everything that we are designing, every single step he's asking me questions. Why this? Why not this? It has just rewired my brain completely. Now I look at every single system in a very different way. I just ask question. I don't need this. My default answer is no to everything. And then I figure out a justification for that. Why do I need exactly this to solve this problem? But a lot of things are learning over here. It's fun. But again, recommend all of you to think critically about everything that you are studying. Don't take everything for granted. Even I love how Rajiv put this question about network partitioning. A lot of people would discard that. But even if you think about it, at least have a solution handy. You may not want to implement that solution, but see how much are you getting impacted. In this case, we were getting impacted for that small thing because it's very low write throughput system. For you to replicate 200 writes, it would take very small amount of time. So your read inconsistencies would be for that very small window that your node joined the cluster before it could get those 200 writes, which is very small. You made a read on that. That is when we are like, so understanding those nitty-gritties is important. So again, recommending all of you to think critically about everything that you're working on, right? Okay, great. Thanks, Sat and Rajiv, for that question. Anubhav, go on.
I had a very small follow-up on this only. So what I want to understand is, can we like over provision replicas from the beginning so that when one of these goes down and
cost, kitna paisa? At the end, it's all about how much extra money are you incurring. If it is not much, over provision. Because
$20 or $15, I think, right?
Yeah. livelihood of your company or the business of your company is dependent on that. Will you, like when you design a flash sale, will you consider, hey, I need to keep my cost down? No, that's a huge event for your organization. You don't want that to go down, no matter what, right? When it's a big thing, this is the only thing that is live on ClickBus. Everything else is just reads on databases. All CRUD operations, CRUD being only read operations. This is the only thing which is live. So it is okay to put some extra cost and over provision your read replicas, and that's perfectly acceptable solution in real world because you are not costing much. So long as it fits into your budget, it's okay. It reduces your stress. It's okay.
Got it. Yeah. Thank you.
Yeah. Okay. Any question? Anyone on ClickBus? Great. Any other question? Anyone? Siddesh, you had one. Go on.
Yeah, but yeah. For the original design, I am still not 100% convinced that we need a Kafka and a Redis, both of them.
Original design is in which one? This recent searches?
Yeah, recent searches.
Yeah, okay.
So what I want to weigh is what are we achieving and what would we miss if we have only one?
Okay, you're saying that because we are writing in two places, there might be a consistency issue.
Yes. Yeah.
Okay. So why do you think it is necessary for us to have strong consistency?
No. I don't think. I'm saying this. That's one problem. I don't think we need to have that. Like, I mean, it's even fine. There's no consistency issue here at all. With respect to the user interface is concerned. A user interface may see a stale one. It's fine. Nobody will even notice what's happening there. My problem is more about the cost that is associated and the engineering efforts that we are putting
Cost
in
associated
terms
with
of
this Redis cluster.
Yes.
To serve the reads. Okay, so if you don't serve the reads from here, you would have to go to a database and serve the reads, correct? Are you suggesting that we go to database to serve the reads?
No. I'm not suggesting that. What I'm saying is, I understand we need Redis because our system is read. Like that is what we are designing, right? What I'm not convinced is why do we need a Kafka to write it back to the database?
So you're saying why can't my search service directly write to the database?
Yes.
Are you sure about this question?
Because
your yes was not confident.
No, I like my yes was not confident because I am still stuck with the original solution of we can either write it to database. I'm still thinking if that what's the problem with that, but I can write it through Redis too.
Okay. You want to write it through Redis. Okay. Now tell me how will you write through Redis?
Yeah. So
in Redis, you have your key. In your Redis, you have key as user ID and value as a list of all the search queries that user has fired. We are storing last 10. Right now, for you to change your design and let it write from Redis to this database, how would that look like?
Yeah. So what I would do is basically in a given batch. So what do we have at the backend is the like a single row based thing, right? Like a document based thing, user ID, timestamp, device, browser.
Storing all of them independently over here.
Yeah, independent. Correct. So basically, one cache entry is on an average, if we take the 10, it's a 10 different entries in the database itself. It does
just
not.
A minute. Hey, just one minute. Here we are only storing the string, the search query. Here it's entire data around it. Timestamp, user ID, device ID, OS, browser, region, and whatnot. So
yeah, I don't like. Okay, I am recommending we can store the whole document. I am
this document
at least as far as my calculation goes. Yeah, I don't think there will be much difference in the size. So we can exactly store as it is, like the array of all the list of all of these searches. Okay. Now what basically the batch ingestion system would do is basically when Redis is like we have A of persistence, so I'm assuming it will do a wall log. Right.
Yes.
So I'll keep reading that wall. I'll have my whatever you say markers on how much I have read and written to the database, and I'll keep proceeding. I want to understand like what is the problem with this system.
No, but then how are you deleting from Redis? Because now you have to also delete from Redis.
No, delete. Oh, I see what you're saying. So I see your point. Okay,
got it.
Basically, you are saying in Redis, what we it doesn't matter, right?
Okay, tell me.
Yeah, because in Redis, each wall log would be like a new user key every time you update one of the keys, right?
No. Here we decided that key is user ID and value is list of things that a user has searched on, right?
Yes,
okay.
yes. So what I'm saying is each persistent entry is also the same thing, right? Okay. What
But
I'm
then
saying
your
is
in-memory Redis now contains more keys. Now you have to delete keys from here, right? You have to delete entries from this list, right? Because you are storing
we
only
are doing
last
that
10.
anyways. The search service is anyways doing that for us. Because
Okay,
whenever
search
you
service is
update,
deleting. Okay, got it. So
search
now your
service
search
is
service
anyways-
is not just appending, but also deleting from here, ensuring that the list is of size 10 always.
No, we also do that in the original design, right? Am I wrong?
Yeah, we are doing it. Yes, we are doing it.
I'm saying a search services, imagine whatever we are doing with the search service, we do the same thing. We have a wall log of those many entries. And if we have the timestamp of how much we have synced, we know what is the change in entries, and we just write those entries back to the database. I understand there is one complexity of handling the list to that. But apart from that, if this can get rid us of the whole Kafka system there, which is, as far as I see, it is only used to like do the batch ingestion, which Redis wall log can help us. What I'm feeling
100%. What I'm just worried about is storing this entire document in Redis for millions of users is a huge overhead.
Got it. Okay.
Because here we are just storing the simple string that user has searched for. But here we have query, timestamp, user ID, device, OS, browser, region, and whatnot other parameters that we add. Storing this in memory of Redis for every query, doing that part over here versus just storing a simple string. I would go with storing of simple string over there, give them explicit set of responsibilities versus storing this huge object over there.
Got it. Yeah. That is
Because
what
now
I
I can
wanted
fit
to
in
make.
more data. Yeah. So my concern is this. So what I'm pushing it in Kafka is I'm pushing this entire detailed object that I would use for analytics purpose and whatnot. But I would just use this to very quickly write this small thing in Redis that, hey, this is just one string. I'll just write it down. That's it.
Got it. So basically you're saying what you write to Redis is something that you are going to read.
Serve to the user. Yes.
Yeah. That makes sense. But what you are going to write to Kafka is something that I want to flush.
It might be much more complex. So right now I'm just envisioning only these part, but it might have
it may be more. Yes. Tomorrow it may get like eventually as your thing grows, you may have much more parameters than just this. And you're
for
like,
example, let me extend one more thing. For example, your search is doing an A/B testing. You want to know this query was served from which version of your search. Those things, those parameters, those segmentations, those cohort of users and whatnot.
Right. Basically, what will happen is eventually, if you try to scale this database, you also have a additional problem of scaling the cache. I see that. That is a major problem.
Now your cache, that's a really nice way to put it. Now the cache can be scaled independently with respect to the amount of data that I'm storing, the actual search query that I'm storing versus, and not because of the complexities that I would incur as part of metadata about this query.
Yeah. So basically, when you are adding something to the database, you are still fine because you don't need to worry about the cache. Because cache, you know what you're going to store. That makes sense. Okay. So eventually that will help throughout. Okay. Now I understand better. Yeah. I was just trying to understand because I am like, if I know if we propose this solution, like there will be question on every component, right? Like why do you need that?
There has to be questions on everything. That's where the fun lies, right?
Yeah.
Nice. Great questions, Siddesh. Loved it.
Thanks.
Thanks. Anupa?
Okay, yeah. First of all, Arpit, I want to say that I have observed that whenever someone is brainstorming or asking a question, they start off with a very scatterbrain and then you give these subtle nudges to send them in right direction. That is very good. Thanks for that. But my question is around, like there is this common feature that we see in recent searches where we are able to delete that. So there's a cross near the recent search button and we hit that X and it's gone from your recent search. So what, like my assumption was always that, okay, this must be stored somewhere in the browser or somewhere in that user's local storage so that you are able to remove it. But based on this system, I think the feature is a bit more complex. You'll have to remove it from Redis and then repopulate that Redis from the source of truth to get the latest in now again, because you may...
in that case, if you would have observed, when you delete them, it does not mean you have to repopulate it from there. You can just continue serving the fewer ones that you have. It's not necessary that you serve exactly 10.
Okay. Okay.
It's a protocol. You can discuss it with the product manager that the complexities involved for you to repopulate it from here versus just serving whatever limited you have over here. Like I have observed in YouTube recent searches, when you tap on it, you see recent searches. When you delete them, next time you only see 4 or 5, the ones that are left there. It does not fetch and populate the 6 that you deleted.
Oh yes, yes. I just checked it. Like it's like that only.
Yeah.
Thanks.
Because see, the engineering complexities is much more. That looks like a no-brainer feature, but imagine the complexities involved for you to do that. And now this shows that YouTube must be doing something very similar to this.
Yeah. Got it. Yeah. Thank you.
Shreya?
I just wanted to hear your story on
Just still stuck on that. Okay, fine. I'll come to that. By the way, thank you for surviving. 14 folks survived. Thanks for that. Okay. Yeah, I forgot what was that all about. What did I say?
How the relational DB failed, and then you went ahead with MongoDB.
That documenting. Okay. So what I was storing is I was storing notifications data. The actual notifications made by the user in a relational database, thinking, hey, it's simple enough. Now I'll just start with relational DB to store this information. Then what happened is we did not anticipate the scale. We did not do any capacity estimation. It was just a quick solution. We built early stage, we shipped, and we forgot about it. Then what happened is because we were storing those, because we were literally storing JSON in SQL, literally JSON, because our data was still unstructured. We had this database up and running. We started storing it in SQL. That started eating up a lot of space. Now, for us to query the data, for us to change anything in that table was becoming impossible. And because it was notification data of the user, it grew very quick. We thought of deleting it, but we said, no, but we want this data to ensure that, hey, that the notification is definitely delivered to this user. So we went with sharding of it. But given that a lot of data was already there in the database, we had to split the database. Now we have to move this table out. Those sort of complexity starts to take in. Which is where we realized that, hey, because we were just storing semi-structured, not totally unstructured, because let me go a little more concrete. What we were actually storing was this user got this notification, and this was the response from the notification provider. For example, if I send notification using Google Cloud Push notification, which is through which you send Android push notification or Apple push notification, we also recorded the response of that. That had a lot of interesting details that we wanted to leverage for marketing campaigns. That document was bloated and we did not even realize because we just wanted to ship something. We quickly shipped that. Now, given that this data was bulky enough, we did not realize that. Now, for us to move this data out of this database, we required a downtime. Now, when we were evaluating the solutions of, hey, where should we put this data? The first thing is we already have relational database. We can take that down, put it into another database. We started with that and we did that eventually, right? So now we took this data because we had to main monolithic database. We had to keep it really small. Why would you want to keep this notification data? Actually, in the first place itself, we should have asked this question, but we're all stupid. We were just building stuff and shipping like Godspeed, every day new feature. We just shipped it whatever we had at hand. Then we took this data, put it into another relational database and let it scale. That data grew very quickly because we had to keep data semi-structured. Why? Because tomorrow Google can add another new fields in notification response, or let's say email provider like Mailgun can add new fields into that. So that data had to be represented in a JSON format. So we had few columns like this user, we were querying on that. This user was received this notification via this channel, and this is the response that we got from the provider. That was the JSON object. Other things were independent columns in that. We created index on top of it. As soon as we created index, our data consumption on the disk blew up. When that blew up, it chopped down the performance of our system because now indexes were bloated. So when we fired any queries on that, because we also ran a bunch of visualization dashboards on top of it, indexes were bloated, reads were slowed down. Now this started affecting the write performance because now reads has to do a lot more work. Writes became slower because of index writes and read load. So now this database We went with relational database because here also relational database, it was easy for us to port. We went with relational database. Then problems had to kick in that our data is semi-structured. We are not querying on a lot of columns, but we still have it indexed. Like, sorry, the columns were there. We were not having index because we were not querying on that. For 2 of the columns, we were querying type of the notification and user ID. But then we thought, how do we solve this problem? Then we thought of let's shard it. Then adding shard, managing it. Then obviously the data was constantly growing. Adding more nodes was a problem. Doing that manually was a problem. We evaluated Percona to do that. And like by getting too complex at hand. And we thought that given the use case that we have, literally every notification is one object. We need indexes on 2 things, 2 attributes. Data is semi-structured. It can grow to any large extent. We want out of the box sharding. Why would we want to do manual sharding? Percona was little too complex for us to do for this part. Relational database was not making a lot of sense in this use case because the data was constantly growing unnecessarily and storing almost not so critical data. I said, let's take a step back and let's move it to MongoDB. And that's where we moved it to MongoDB because number 1, the data was semi-structured. Number 2, it did give us indexes that we want, 2 attributes and not on the detailed object that we had. 2 attributes indexes it gave us. Third, it gave us sharding, seamless sharding. We don't even have to have a proxy. MongoDB handles that for us. Fourth, it helped us ensure that sharding is handled, like the proxy part MongoDB automatically gives you, but sharding is handled by MongoDB. So if I add more nodes to that, rebalancing and all, it would take care. We don't have to worry about it. So all sorts of engineering efforts that we would have put into managing that became a no-brainer when we went for MongoDB. That's why we chose MongoDB.
Got it.
That's the story. And
Thank
had
you
a
so
ton of learning. We made a lot of stupid decisions, but that's what made me understand that asking those critical questions is very important. We should have actually gone with MongoDB or even DynamoDB for that matter on day 0 itself, but we did not. And that's the blunder that we made that day. But then we moved that service out of MongoDB into DynamoDB because AWS, we were tightly coupled on AWS. Why to have another cloud provider use MongoDB, Atlas and whatnot? We just took that thing and put it onto, which is that DocumentDB, which is MongoDB port of AWS. We dumped it there. Problem solved. One such problem. Not DynamoDB, but the document. I wanted to say DocumentDB. So DocumentDB is a port of, which is MongoDB compliant document database on AWS. So we ported it. Right. So that our application logic doesn't change. Our dashboards did not change. We just moved from this MongoDB, like this data. We ran it for 6 months only. We took this data, put it into DocumentDB. And sorry, DocumentDB, AWS managed DocumentDB. I think it's a document. It's called DocumentDB. 3 years ago. Yeah. Hopefully that answers some of your questions on that.
Yeah. Thank you so much.
Yeah. Super. Okay. Any other question, anyone? 12:42. We go it for 15 minutes. We have 4-hour sessions. But yeah. Thanks, folks.
Hey,
Great questions. Go on, Siddesh.
Yeah. So, are you going to cover anything related to Elasticsearch?
Kya cover? Batao. What specific you want me to cover?
No. I have never used one.
No, it's not part of the plan. But just use it. Use it once. At a lot of things that, and obviously the things that I talked about in the relevance part, a lot of things would make sense once you start using Elasticsearch and you understand the limitations of it. So take any dump from Kaggle, any data set, ingest it in Elasticsearch, play around with that and see the kind of queries you can fire, analyzers and whatever, tons of things in that. It will be overwhelming at first. Yeah, it will be overwhelming at first because writing JSON-based queries is a little tricky with Elasticsearch. Knowing what all goes where, it's a little tricky there. But go through that grind. Once you understand Elasticsearch well, you'll understand the limitations of it. Then you'll understand how these all comes into the picture. Okay?
I see. Okay, cool. Yeah, thanks for this point. Yeah.
Rajiv?
Arpit, one insight I want to help from you. It looks like you have got hit by a large number of traffic. Basically, that's why you developed so much insights of what is very small, what is very big, and what kind of DBs are that. I know that you have been asking us to implement all these features on our single machines, and I've been doing that basically. But that I feel like when you handle traffic, that's where you get insights. Okay, what works, what doesn't work, what is the real field effect, right? So
100%.
I don't have exposure to traffic, unfortunately. How do one point to a different direction? Okay.
You'll get those experience. Don't worry, because you are just preparing yourself to be able to handle it that day. Right? At least because what I believe is, if you start worrying about traffic on day zero, like while you are learning, if you are thinking of traffic, what's stopping you? Then you are adding the pseudo blockers in your head. Because when the time comes, this is one mistake that I made, right? So I'm actually talking from my experience. So what I would have done differently is I would have been much more hands-on than when I started being hands-on. Now, what happens is when you work at that scale, and I've not handled very massive scale, to be honest, at few places here and there I've handled, but I can actually connect the dots on those insights that I got from that. Now, what happens is when you are given into that, when you're into that critical situation, when you're handling that scale, you should not be spending time solving for those basics. You are just leveraging the time when you're handling that scale into understanding how things operate at scale and not worrying about those basic parts. That's where doing this, knowing those low-level implementation detail will just help you understand those potential bottlenecks that would help you connect the dots when you work at scale. Because nothing beats your actual production experience. I got 3 times that experience of handling massive scales, just 3 times. But at 3 times with different databases, it helped me understand and connect the dots really well, because I was hands-on on a lot of other stuff. I could easily see what could go wrong, what could happen, where reads become slow, where writes become slow, why are we doing something a certain way. Right? So for me, when I ask you all to implement it on single machine, it's about me trying to prepare you for that low-level implementation detail so that some dots are there. When you hit that scale, that becomes easier for you to connect them. That, hey, what could have gone wrong? And you would spend less time into understanding those basics.
Yeah, right.
That's right. But keep load testing your single server and see how it reacts. You'd still uncover most of the problems there. Right. And then maybe if you're working with relational databases or even non-relational databases, see how your query plans are created. In most cases, throughout this course, you would have seen how it's all about databases. It's always about databases.
Brittle
right?
component, yes.
Right. So that's the most brittle component. So once you understand how queries are created, how they're executed, how they're evaluated, that's where the magic sauce lies. Just focus on that. And that you can do on local machine itself, that understanding those query plans, so that when you attain that scale, you understand, okay, now my database isn't deadlocked. Now this is what would have happened. This is how my transactions would have restarted. This is how my write logs would have been distributed. And what? You'll get those things there. Right? So explore that part a bit. Like once you know how to see or evaluate a query plan and understand how your database would be doing it, once you see those things in production, you would easily be able to connect the dots. That's my approach to do that, because instead of getting blocked on quote unquote scale, I would have just get a lot of exposure around this part. And then once I'm thrown into that situation, it would be easier for me to understand how things are. Right.
Yeah,
so
understood. Yeah.
Sure. Super. Great, folks. Thanks, folks, for tuning in. Again, I've left the links in the comment. Please leave me a testimonial. It would mean the world to me. Last 1 week, like next week is the last one. Tomorrow we'll have fun discussion. Tomorrow we'll design flash sale. Yes, the last system we'll design tomorrow is flash sale, and then 8th week is all about algorithmic system design. But yeah, we'll have very nice fun tomorrow. A lot of ad hoc systems will design and a lot of brainstorming. So gear up for that. And I'll upload the recording by evening. Meanwhile, please write my testimony. Chalo. Thanks, folks, for tuning in. See you tomorrow morning 9. Bye-bye.